process in your graduation level. So the spontaneous process is that process that occurs on their own under a given set of conditions without the aid of any external agency. So that will continue automatically without the support of any external agency. As a chemist, it is of interest to be able to predict the feasibility of a chemical reaction. However, the internal energy enthalpy cannot predict the spontaneity of a process that we have already studied in graduation level. In order to predict the spontaneity of a, already we have discussed in the graduation level that internal energy and enthalpy cannot predict the spontaneity of a process. So this led to introduction of a new state function that is called entropy that could serve as a criteria for spontaneity. But the entropy does not define the effectively the spontaneity of the process. So before that, we should discuss some mathematical functions that is called Clausius inequality. So here, let us consider two processes taking place between same initial and final state. So here the initial state is state 1, that is initial state, and this is state 2, that is the final state. So we assume that one of these processes takes place under reversible condition and the other one takes place under irreversible condition. So here from state 1 to state 2, two processes are going on. So the first one is from 1 to 2, that is process number A, and another one is 2 to 1, that is process number B. So here we have to assume that out of the two processes, one of the process will take place under reversible condition and the other one under irreversible condition. And after that, since internal energy is a state function, the change in internal energy of this process will be equals to du reversible equals to du irreversible. So here U is the sign of internal energy, and internal energy is a state function. State function means the function which will only dependent upon the state of the system, that does not depends upon the path followed. So here in both the reversible and irreversible process are taking place, but here only we are considering change in internal energy, and internal energy is a state function. So only we will consider about the state 1 and state 2. We should not consider about the path follows, path A or path B. And hence, the change in internal energy in the reversible condition equals to change in internal energy in the irreversible condition. That is du reversible. Du means change in internal energy. So du reversible equals to du reversible equals to du irreversible. And again, you should know that the mathematical statement of first law of thermodynamics that you have already studied. So this is the mathematical statement of first law of thermodynamics. Now, according to first law of thermodynamics, du equals to dq plus dw. And in terms of first law, again we can write dq reversible plus dw reversible equals to dq irreversible plus dw irreversible. Because so this is the first law. So this is the mathematical statement of first law of thermodynamics. Now, if we apply this mathematical statement of first law of thermodynamics for du reversible, you can write dq reversible plus dw reversible. And similarly, if we apply the mathematical statement in irreversible process, you can, instead of du irreversible, you can write dq irreversible plus dw irreversible. Now, rearranging the above expression 1.3, if we rearrange the equation 1.3, taking dq into one side and dw another side. We can write dq reversible minus dq irreversible equals to dw irreversible minus dw reversible. Here, the dw represents the work done on the system. As you know that the work done on the system is a
Hello,
positive.
sir.
So,
Excuse
hello,
me, sir.
yes, yes,
Hello, sir. Sir,
hello.
please kindly share the screen, sir. We cannot the
Same
visible
thing,
the
sir.
screen.
Same thing.
Okay, okay,
Will unable to be visible.
Your screen is not visible, sir. Please kindly
okay,
share the
okay.
screen.
Okay, now is it okay? Visible? Hello?
Yes, sir.
Whether
Yes,
the
sir.
Yes, sir. Visible.
screen is
Yes, sir.
visible
Visible.
now? Okay. So just we have
Yes,
Yes,
sir.
started
sir.
from the Helmholtz function. Before that, we have discussed about the Clausius inequality. So from the Clausius inequality, as the change in internal energy is a state function. So here we are considering two states. State one is the initial state, and state two is the final state. So the work is going on from state one to initial to final state by two different processes or by two different paths. That is path A and path B. So here two different from both of the paths we have assumed that one process and we can apply this mathematical statement of fact law of thermodynamics. In the equation 3, taking dq into one side and dw into another side, we can write dq reversible minus dq irreversible equals to dw irreversible minus dw reversible. This is equation number 4. And here dw represents the work done on the system. And again we know that whenever we are according to the law of thermodynamics in chemistry, we should assume that when work is done on the system, that is one positive work, and if work is done by the system, that is negative work. So here dw represent work done on the system, and as you know that the work done on the system is positive, its magnitude during the reversible process is greater than during the irreversible process. So that is a general principle that always work done in the reversible process is greater than work done in the irreversible process. So magnitude of work done in the reversible process is greater than magnitude of work done in the irreversible process. Now, if we see equation number 4, definitely the RHS will be a positive. The RHS will be a negative term because the work done in the reversible process is always greater than work done during the irreversible process. So rearranging this, we can write dw irreversible minus dw reversible is greater than 0. And substituting this value in equation 4, we can write dq reversible minus dq irreversible is greater than 0. Now dividing this equation 1.7 by temperature T, that is the absolute temperature, we can write dq reversible by T minus dq irreversible by T, that is greater than 0. And if we generalize this equation, we can write, and again this term dq by t is nothing but change in entropy. If we uh, so recall that for a reversible process, the change in entropy, that is ds equals to dq reversible by t, and after putting this value in equation 1.8, we can write ds minus dq reversible by t is greater than 0, and hence ds is greater than dq irreversible by t. Now combining this expression for entropy change during the reversible process in 1.9, we can write that ds is greater than equals to dq divided by t. In the graduation level, we have studied that ds equals to by t, that is change in entropy equals to work done divided by absolute temperature, change in temperature. But here we are finding that ds is greater than equal to dq divided by t. And this equation is known as Clausius inequality. This expression will be used later to arrive the expression of spontaneity of thermodynamic process. So this Clausius inequality will use in the when spontaneity of thermodynamic processes. Now coming to the combination of first and second law. Again,
Excuse me, sir.
hello, yes.
Hello. सर स्क्रीन फिर से विजिबल नहीं हो रहा है.
Is it okay?
अभी हुआ. Is it okay,
Okay.
sir? Okay, sir.
So this equation, you should know that this equation 11, this is the equation. This equation is known as Clausius inequality equation. This equation, again I am telling, this equation known as Clausius inequality equation, because in our graduation level we have studied that ds is equals to dq by t. But according to the Clausius inequality, ds is greater than equals to dq by t. So ds is nothing but change in entropy. So this expression will be used later whenever we'll derive the expression for spontaneity of thermodynamic processes. And after that we will go to the combination of first and second law. Again, you should remember the first law of thermodynamics, that is du equal to dq plus dw, and consider a, so here consider a case in a closed system that containing a gas having a constant composition which undergoes a reversible change in such a way that only work of expansion is permitted. So this is the condition. Here we have to consider a case in a closed system where in the closed system a particular gas will be there, and only work of expansion will be permitted. As work of expansion will be permitted, when the gas will undergo expansion, in that condition work will be done by the system on surrounding. And again, when work will be done by the system, that work is called a negative work. Since we are considering a reversible expansion, the opposing pressure would be equal to pressure of the gas. Therefore, dW reversible equals to minus PdV. So here negative side is there because here we are considering work of expansion only. Because we are considering only the work of expansion. Equation number 12. Now from equation 9, here we have discussed this one. So this is the equation 9. Ts equal to dq reversible by t. So in the reversible condition, if we apply dq equal to tds, so from this equation 11, equation 9, we can write that dq reversible equal to tds. From equation 9, we can write dq reversible equal to tds. Now putting these values in place of dq reversible, we can write tds in place dq reversible, we can write tds, and after that substituting from equation 12 and 13 in equation 2, So here this is equation 2. If you put the values of 12 and 13 in equation 2. Equation 2 is the mathematical statement of first law of thermodynamics. That is du equal to dq plus dw. Here we are putting the values of dq and also the values of dw. So whenever we will put the values of dq and dw, the equation will be like this. Then du equal to tds minus pdv. Here we have find out the value of dw, that is minus pdv, and here we are putting the value of dq reversible equals to tds. So putting both the values in the mathematical statement of first law of thermodynamics, we can write du equals to tds minus pdv. So this is this combined expression. So this is the combined expression of first and second law is called fundamental thermodynamic equation. So the exam question may come, derive the now coming to entropy change, that is a criteria of spontaneity, because we have already discussed that spontaneous process is a process that will take place automatically without the aid of any external help. So that is called spontaneous process. And non-spontaneous process is a process that will carried out with the support of continuous external help. So if we remove the external help, then the process will stop. So that is known as non-spontaneous process. But here we are discussing about the spontaneous process or the irreversible process, because all the spontaneous processes are irreversible. So according to the spontaneous irreversible process, again we know that change in entropy of the system plus change in entropy of the surrounding, that is del S system plus del S surrounding, equals to change in entropy of the universe, that is greater than zero. So from this we can find out that, but so this equation is valid for irreversible process or spontaneous process. But whenever the process will be reversible process, for reversible process, del S system plus del S surrounding equals to del S universe, that is equal to zero. That means for spontaneous process or for reversible process, the total change in entropy of the universe is zero. But for irreversible process, the total change in entropy of the universe is greater than zero. That means the total entropy of the universe is gradually increasing, because all the naturally occurring processes in the universe are irreversible. In other words, we would say that in an isolated system, the total entropy of the universe increases in an irreversible process and remain constant for reversible process. Again, I am telling, in other words, we can say that the total entropy of the universe increases in an irreversible process and remain constant for a reversible process. So for a reversible process, the del S total equals to zero. So that means there is no change in entropy, and hence for a reversible process, the total entropy change will remain constant. But for irreversible process, del S universe is greater than zero, and hence the total entropy of the universe increases in an irreversible process. So thus we see that entropy change does provide a criteria for establishing the spontaneity of a process. However, there is a limitation in applying this criteria to different systems, as it is required to calculate the entropy changes of the system as well as of the surrounding. So if we will take entropy as the criteria for spontaneity of a process, it is required to calculate the total entropy change of the system as well as the total entropy change of the surrounding, which is a very difficult thing. And hence, we have to find out a new function which will define the criteria of spontaneity of the system. So now the new function is Helmholtz energy change, That is the criteria of spontaneity and equilibrium. So in chemistry, the processes are carried out under constant temperature and constant pressure conditions. So here we will consider the process will should be carried out at constant temperature and constant pressure. That means open process. So just like the process what is carried out in our laboratory, and accordingly we have two functions to predict the spontaneity of a process depending upon the reaction condition. Now let us begin with the processes carried out under constant temperature and constant volume conditions and deduce a function that can act as a criteria of spontaneity of such cases. And again we should remember, according to first law of thermodynamics, a process involving only mechanical work and the change in internal energy will be given by du equals to dq plus p del v, but here negative sign is there as we are considering expansion work. So when the system will undergo expansion, then work will be done by the system. So when work will be done by the system, there will be one negative side. If the system will undergo compression, then work will be done on the system, then positive side will be there. So only sign convention will be changed. So here, according to first law of thermodynamics, as we are considering expansion work, the system will expand against a constant pressure. So the mechanical work will be minus P del V, and hence the change in internal energy du equals to dq minus P del V. Now let us consider the processes where only heat flow is taking place between the system and surrounding and no mechanical work is involved. So if no mechanical work will be involved, that means the system will not undergo any type of compression or expansion. Then the PdV term will be 0, and if only heat will be exchanged between the system and surrounding, then change in internal energy du equals to dq. So according to Clausius inequality, so this is the equation of Clausius inequality, ds is greater than equal to dq divided by t. Now if we put these values, we can write so from this equation we can write TdS is greater than equals to dq. Now comparing this equation 18 and 19, we can write du is less than equal to TdS, because TdS is greater than equal to dq, and if the no mechanical work is involved, then du equals to dq. So we can write TdS is greater than equal to du. That is, du is less than equal to TdS. And again, du minus TdS is less than equal to 0. So here, u is nothing but du is nothing but change in internal energy, that is a state function. ds is nothing but change in entropy, that is a state function. Since u and t are state functions, a combination of two state functions will also give rise to another state function. So here we have to introduce a new state function, that is called a, capital A. So the new state function is known as Helmholtz function, and the sign of the Helmholtz function is capital A. So from this equation we can write a equals to u minus ts. A is known as the Helmholtz function, u equals to internal energy, T is the absolute temperature, that is constant, and S is nothing but the entropy. So if we'll find out the unit of Helmholtz function A, since the unit of internal energy and the term Ts are the same dimension, that is nothing but that is equal to so for so the unit of T is Kelvin and the unit of S is joule per Kelvin, and hence the unit of Ts will be joule and the unit of internal energy will be joule, and hence the unit of Helmholtz function will also joule. Therefore, A, that is the Helmholtz function, is also referred as Helmholtz energy because its unit is J. So having the SI unit joule, J means joule. When the process is carried out under constant temperature condition, the change in Helmholtz energy or the change in Helmholtz function, that is called change in Helmholtz energy, can be written as dA equal comparing equation 20 and 22. So this is the equation 20. 20 is like this, du minus TDS is less than equal to 0, and this is equation 22. So here dA is there. So dA at constant temperature and constant volume is less than equal to 0. So why we are considering constant volume? Because initially we have considered no mechanical work will be there. That means no change in volume. We have initially assumed a spontaneous heat flow at constant volume and have applied at constant temperature condition in equation 1.2 in equation 21. Thus, the equation 23 provides the criteria for spontaneity and equilibrium of a process taking place at constant volume and constant temperature. So, here this is the equation 23 is like this. dA is less than equals to 0. So if dA is less than 0, the process will be spontaneous, and if dA equals to 0, the process will be in equilibrium. And again, for an overall change, del A or for a bulk change, if del A means change in Helmholtz free energy or Helmholtz energy, change in Helmholtz energy. So when del A is less than 0, the process will be spontaneous. And when del A equals to 0, the process will be in equilibrium. And again from this finite change, so this is for finite change, so that is del A equals to del U minus T del S. For finite change taking place at constant temperature and constant volume, the criteria for spontaneity is del A less than 0, and the criteria for equilibrium is del A equals to 0. And combining both, we can write del A at constant temperature and constant volume less than equal to 0. So this is for finite change, and this is for infinitesimal change or very small change. So these are the criteria for spontaneity of process. Now coming to the condition for spontaneity and equilibrium. So combining equation 24 and criteria, so this is equation 24, this one, so this is for finite change. Equation 24 is del A equal to del U minus T del S. So this is equation 24. Now combining equation 24 and the criteria for spontaneity. Criteria for spontaneity is del A less than 0. That means the value of del A should be negative. We find that spontaneity of the process at constant temperature and constant volume depends upon the combination of change in internal energy and change in entropy of the system, because we know that del A equals to del U minus T del S. So here we are putting del U minus T del S is less than 0. So this is the condition for spontaneous process. Because for spontaneous process, we have already discussed that for spontaneous process, del A should be negative. That is, del A should be less than 0. So in place of del A, we are writing del U plus del U minus T del S less than 0. So this is the condition of spontaneous process. And if the process will be in equilibrium, then del A minus del U minus T del S equals to 0. But here this is the spontaneous condition. Now coming to case 1. So in the case 1, if change in internal energy is less than 0 and change in entropy is greater than 0, in this case, the value of del U minus T del S will be negative for all temperature, and hence the process will be spontaneous for all temperature. Again, I am telling, if there is if there is decreasing internal energy, and increase in entropy, then at any temperature, the value of del U minus T del T del S will be negative. So the process will be spontaneous at all temperature. Now coming to case number 2. So in the case number 2, if del U is greater than 0, that means if there is increase in internal energy, and del S is less than 0, that means if there is decrease in entropy. Then in this case, in order to get spontaneous process, del U minus T del S value will be always positive, and hence the process will never be spontaneous. This is case. Again, I am coming to that previous one. So this is the condition of spontaneous process. We have derived that this is the condition of spontaneous process. So for spontaneous process, the condition is like this: del U minus T del S should be less than 0. And if del U means change in internal energy, T is the absolute temperature at constant temperature, and del S is change in entropy. So the equation is like this: del U minus T del S should be negative or should be less than 0. So this is the condition of spontaneous process. So if we apply this condition to various cases, here we are discussing for case 1 less than 0. Del U less than 0 means there is decrease in internal energy.
I am
There
not
is decrease
able to
in entropy.
see the
The
screen.
process will be continuous at all temperature. That means for any value of T, the value of del A will be negative. That is the value of del U minus T del S will be negative. So this is case 1. Hello. Okay, actually some network problem was that at that time some network problem was there. Now it is okay.
Yes, sir. Your screen is not
Okay,
visible,
okay.
sir.
So I'm just reconnecting. Some network problem was there at that time.
Okay, okay, sir.
Now, is it okay?
Okay, sir. Sir, screen is not visible yet. Huh, now it is visible.
Okay. So this is the criteria. So this is the condition for spontaneity. So that is del A should less than 0. Del A means change in Helmholtz energy should be less than 0. So del A means del U minus T del S should be less than 0. Now if you apply this condition to various cases, so these are the various cases. So if you apply this condition to various cases, so this one is case 1. So in case 1, you can see when del U is less than 0 and del S is greater than 0. That means del U less than 0 means change in entropy is less than, change in internal energy is less than 0. That means internal energy will decrease. And del S is greater than 0 means change in entropy is greater than 0, that is entropy will increase. So that means the case 1 involves with the process where internal energy will decrease and entropy will increase. So in this case, the value of del U minus T del S will always negative. So for all temperature, the process will be spontaneous. So this is case 1 when del U less than 0 and del S greater than 0. At any temperature, any value of temperature, the process will be spontaneous. Now coming to case 2. So in the case 2, when del U greater than 0, that means there is increase in internal energy, and del S less than 0, that means there will be decrease in entropy. So in this case, the value of del U minus T del S will be always positive, and we know that if the value of del U minus T del S will be positive, the process will never be spontaneous. Now coming to case 3. So this case is one important case. Why this is important case? Because here we have to take the value of temperature. So in this case, what is happening? In this case, del U will be negative and T del S will be positive. Again, I am telling. In this case, del U will be negative and T del S will be positive. So at certain temperature, the magnitude of this will be equal. So that means del U will be negative and T del S will be positive. But at certain temperature, their magnitude will be equal. So in that case, magnitude of del U minus will be equals to magnitude of T del S. So in that case, del A will be equals to 0 and the system will be in equilibrium. So if the magnitude of del U and magnitude of T del S will be same, in that case the system will be in equilibrium. This temperature may be called equilibrium temperature, and if we want to find out the equilibrium temperature, so here the equation will be like this. Magnitude of del U equals to magnitude of T del S. So T equals to magnitude of del U divided by magnitude of del S. So that is called equilibrium temperature. So at that temperature, the system will be in equilibrium. Now coming to the case 4. So in the case 4, del U will be positive and del S will be positive. That means both entropy and internal energy will increase. In this case, both the del U and T del S term will be positive. Here again, a certain temperature, the magnitude there will be same. At a certain temperature, the magnitude of both term will be same. That is del U, magnitude of del U equal to magnitude of T del S. And in that condition, del A equals to 0. So that means the system will be equilibrium at this temperature. But here, if you want to find out the condition of spontaneous condition or the criteria for spontaneity of the process, now such processes only is spontaneous when the magnitude of del U is less than the magnitude of T del S. So that is magnitude of del U should be less than magnitude of T del S. So this condition will be arise at a temperature higher than the equilibrium temperature. So that means So here in this condition, we can find out the equilibrium temperature. Equilibrium temperature is T equals to del U, magnitude of del U divided by magnitude of del S. So if the temperature will be i- if the temperature will be higher than the equilibrium temperature, then the process will be spontaneous. Similarly, in the fourth case, if the temperature will be lower than the equilibrium temperature, then the process will be spontaneous. Now coming to the case 5. So in the case 5, in such cases, the process will be spontaneous only for exothermic processes. So for exothermic processes, energy will be released from the system and hence there will be decrease in internal energy. So for exothermic processes, if del U is less than 0, such process will be equilibrium when del U equals to 0. And again coming to the case 6, when del U equals to 0, in this case the process will be spontaneous only if the value of del S will be greater than 0. Why? Because here we are subtracting the value of T del S minus, here we are subtracting the value of T del S from the value of del U. And if and here we are considering in the case 6 the value of del U should be 0, and hence the process will be spontaneous if the value of del S will be greater than 0. So that means the value of del S should be positive. So if the value of del S should be positive, then the value of T del S will be positive and the value of minus T del S will be negative and the process will be spontaneous. So whatever we have discussed in the 6 cases, so the all the 6 conditions are summarized here. You can see the condition of spontaneity and equilibrium for different combination of del U and del S processes. So if the first one is serial number 1, combination of del U and del S. If del U is less than 0 and del S is greater than 0, the process will be spontaneous at all temperature. Equilibrium will not be observed. And if the value of del U greater than 0 and del S less than 0, the value will be non-spontaneous at all temperature. Equilibrium will not be observed. So these are the condition of equilibrium, but this condition will not arise. And in the case 3, whatever we have discussed, del U less than 0 and del S less than 0. So in that condition, the equilibrium temperature T equals to magnitude of del U by magnitude of del S. The process will be spontaneous at temperature lower than the equilibrium temperature. And similarly, in the case next case, del U is greater than 0 and del S is greater than 0. And here the value of the equilibrium temperature T equals to magnitude of del U by magnitude of del S, and the process will be spontaneous at temperature higher than equilibrium temperature. Now coming to the next condition where del S equals to 0, that means that term will be vanished and the process will be spontaneous if the value of the RHS will be 0, will be less than 0, that is will be negative. So when del S term will not be there, the process will be spontaneous when del U is less than 0, that is for exothermic process. And similarly, when del U equals to 0, the process will be spontaneous when the magnitude of del S will be greater than 0 and the entropy must increase in order to attain the spontaneity of the process. That means the value of del S will be greater than 0. But here in this column you can find out the condition for equilibrium. So here we have discussed the first expression for the spontaneity of process, for the condition of spontaneity of process at constant temperature and constant volume. So this is first long question, that is called Helmholtz energy change. So that is the criteria of spontaneity and equilibrium. All of you understood? Hello?
Yes.
Okay. So here we will okay. So here we will discuss one example, numerical example. So the question is like this: during an isochoric isothermal process, Isochoric means the volume will be constant, and isothermal means the temperature will be constant. That means Helmholtz free energy factor will be there in order to define the spontaneity of the process. So during an isochoric and isothermal process taking place at 25 degrees Celsius, the internal energy change of the system decreased by 20 kilojoule per mole, and the entropy will be increased by 50 joule per Kelvin per mole. Calculate the change in Helmholtz energy. That means you have to find out the value of del A. Already we have, so the values are given. Which values are given? So here the first one is internal energy change of the system decreased by 20 kilojoule per mole. That means del U equals to minus 20 kilojoule per mole, which is equals to minus 20 into 10 to the power 3 joule per mole. And similarly, del S entropy increased by 50 joule per Kelvin per mole. That means del S equals to 50 joule per Kelvin per mole. So that is increased and internal energy decreased. So that's a negative sign is there. And the temperature is 25 degrees Celsius, that is 298 Kelvin. Always you should use absolute temperature in any type of numerical questions. And the question is like that, we have to find out the value of del A, and again we know that del A equal to del U minus T del S. Just putting all the values, we can calculate the value of change in Helmholtz energy. So that is del A. Now coming to the physical significance of the Helmholtz energy. So as per the previous equation, the change in Helmholtz energy for infinitesimal change, that is dA equals to du minus T del S. For finite change, del A equals to del U minus T del S. But for infinitesimal change, dA equals to du minus T del S. And again, we can recall the first law of thermodynamics, du equals to dq plus dw. Now putting the value of dq plus dw, putting the value of dq plus dw in here, we can write dq equals to tds, and again from another equation for the reversible system, we can write dq reversible equals to tds. Now combining all, so if we put the combined expression of first and second law, we can write du equal to tds plus dw reversible. Now substituting these values in equation 22, we can write dA equals to, in place of du, we can write tds plus dw reversible minus tds. So dA equal to dw reversible. Now according to this equation 31, change in Helmholtz energy equals to work done during isothermal reversible condition. When Helmholtz energy decreases, the value of W reversible will be negative, indicate work is done by the system. Therefore, the decrease in Helmholtz energy equals to work done by the system during the, because if the so here dA equals to dW reversible. So when Helmholtz energy decreases, the value of W reversible will be negative, that indicating work is done by the system. W reversible will be negative means work is done by the system. Therefore, the decrease in Helmholtz energy equals to work done by the system during isothermal reversible process. This work includes all type of work that system can do. Hence, Helmholtz energy change is related to maximum amount of work that can be obtained by a system, and that's why that is called work function. So this is the physical significance of Helmholtz energy or Helmholtz function. Now, after the Helmholtz energy or Helmholtz function, which define the criteria of spontaneity of the thermodynamic processes, another function is there, that is called Gibbs function, which also define the criteria of spontaneity also. So let us consider the spontaneous heat flow taking place between the system and surrounding at constant pressure. In the previous case, we have discussed at constant volume, but here that is at constant pressure. When the process will be carried out at constant temperature and constant volume, you should use Helmholtz free energy or work function. But if the process will take place at constant temperature and constant pressure, a new term will be there that is called Gibbs function or Gibbs free energy. So here we are considering that heat flow taking place between the system and surrounding at constant pressure. You know that such a heat flow is equal to change in enthalpy of the system. In the previous case, if heat flow will taking place between system and surrounding at constant volume, the heat flow equal to change in internal energy. But as here the heat flow taking place between the system and surrounding at constant pressure, so here the heat flow is equal to change in enthalpy. So when at constant temperature and volume, the heat flow is change in internal energy, and when the process will take place at constant temperature and pressure, the heat flow is equal to change in enthalpy. So that is dH equals to dQp. P means at here the subscript P is there. That means at constant pressure. So here dH equals to dQ at constant pressure. Now again, if we use Clausius inequality, so you can see that in both this long question, Clausius inequality is used. So that's why before that we have derived the Clausius inequality. So this is equation 32. In the equation 32, the heat flow at constant temperature and pressure is nothing but change in enthalpy of the system, that is dH equals to dQ at constant pressure. And using the Clausius inequality, that is TdS is greater than dQ. So this is equation 32 and this is equation 33. Now combining both the equations, we can write TdS is greater than dH. So here dH equals to dQ at constant pressure, and again TdS is greater than equal to dQ. So TdS is greater than equal to dH, and hence it can be rearranged that dH minus TdS is less than equal to 0. So this equation 35 holds for a process. Again I am repeating the same thing. The equation 35 holds for a process taking place at constant temperature and constant pressure. The previous one, that is dA minus TdS, when the process were taking place at constant temperature and constant volume. But here the process taking place at constant temperature and constant pressure. So that's why instead of using dA minus TdS, so in the previous cases, you can remember we have used the equation dA minus TdS less than equal to 0. But here we are using du minus TdS less than equal to 0. But here we are using dH minus TdS less than equal to 0. Here the process is taking place at constant temperature and constant pressure. Now, so this is the condition taking place at constant temperature and constant pressure. Since the LHS of this equation is a combination of two state functions H and S, it will also be a state function. So here enthalpy is a state function, entropy is a state function, and temperature is constant temperature. So that's why the LHS of equation 35 is also a state function. So that state function will give rise to a new function that is called Gibbs function or Gibbs energy, which is the honor of American chemist J.W. Gibbs. And in order to define the Gibbs function or Gibbs energy, we can write it is represented as G, and the mathematical definition G equals to H minus Ts. And again, since the entropy, the unit of enthalpy and unit of Ts term are both same, that is Joule. Exactly similar type of explanation we have studied in case of A, that is Helmholtz energy. And here similar type of expression is there. So G is also have the units of energy. That's why that is called Gibbs energy. In the previous case, we have discussed that Helmholtz energy. Now it is Gibbs energy. So the SI unit of Gibbs energy is Joule. When the temperature is kept constant, The infinite, so for infinitesimal change of Gibbs energy, we can write dg equals to dh minus tds. So this is equation 37. So similar type of derivation you can see. So here from equation 35, that is so the equation 35, this one. So this is the condition, that is for spontaneity dh minus tds should be less than 0. So equation 35 is valid for the processes taking place under constant temperature and constant pressure condition. Now comparing equation 35 and 37, we can write a process taking place at constant temperature and pressure. The Gibbs energy change of the system is less than equal to 0. So that means dg at constant temperature and pressure less than equal to 0. If the value will be less than 0, that is spontaneous process. If the value equals to 0, that is in equilibrium. So here this is the criteria of spontaneity and equilibrium. While derive the criteria of spontaneity of a process occurring at constant temperature and constant pressure condition in terms of Gibbs energy, we also use the Clausius inequality what we have studied in the initial. It implies that we have taken account of both reversible and irreversible processes. Let us now take the reversible and irreversible processes separately. So first we'll discuss about the criteria for reversible process. For reversible process, we can write TDS equal to dq reversible. This is this thing we have also discussed in equation 13. And again, as per equation 32, we can write dh equals to dq, this one. This one, dh equals to dq at constant pressure. Now, according to equation 32, we can write dh equals to dq at constant pressure. Now, comparing both these equations, we can write dh equals to dds. Here we are only discussing the reversible process at constant pressure. So in the equation, from equation 13, we can write TDS equals to dq reversible, and from the equation 32, we can write dh equals to dq at constant pressure. So comparing both these equations, we can write dh equals to tds, that is dh minus tds equals to 0, and again dh minus tds is nothing but dg, so dg equals to 0. So this is for reversible process. This implies for a reversible process. Now for irreversible process, we know that tds is greater than dq reversible, and substituting this values in equation 37, means this one, dg equals to ds minus tds. Now putting these values in equation 37, we can write dg is less than 0. Since all spontaneous reactions are irreversible, equation 42 serves as a criteria of spontaneity of a process occurring under constant temperature and constant pressure. Previously, we have discussed the criteria of spontaneity of a process occurring under constant temperature and constant volume. So now this is the condition of criteria of spontaneity of a process at constant temperature and constant pressure. Now coming to relationship between spontaneity, Gibbs energy, and entropy of the universe. So again, according to the second law of thermodynamics, the entropy change of an isolated system is equals to or greater than 0 for spontaneous processes, that is ds is greater than equals to 0. For isolated system, ds equals to 0 for reversible process and ds greater than 0 for irreversible process. Thus, the system and its immediate surrounding can be assumed to be isolated from the rest of the universe. Such system is said to be composite isolated system, and the total entropy for such system is given by this expression: ds total equals to ds system plus ds surrounding. And since and from this value we can find out ds surrounding equals to ds system, ds total minus ds system, and hence ds surrounding is equals to dq surrounding by t, because we know that ds equals to dq by t. So ds surrounding equals to dq surrounding by T equals to minus dq system by T. Hence, we know at constant pressure dq system equals to dh system. Again, same thing we have discussed here at constant pressure. This one dh equals to dq. So putting this that condition at constant temperature and constant pressure, we can write a dq system equals to dh system. And hence, so this is and hence again we can write expression 44. This one is expression 44. So ds total equals to ds system minus dh system divided by T. That means in q, in place of dq system by T, we are putting dh system by T. And again simplifying ds total equals to tds system minus dh system by T. And again rearranging that one, ds total equals to, so dds minus dh is nothing but dg, because we have already defined a new function dg equals to tds, this one dg equals to dh minus tds. So here we are putting dds minus dh means minus dg. So ds total equals to minus dg system divided by T. And since ds total increases for a spontaneous irreversible process, therefore for a spontaneous process at constant temperature and constant pressure, we say that minus dg system divided by T should be greater than 0. That means dg system should be less than 0. So this is the desired criteria for spontaneity of a process under constant temperature and constant pressure condition. Therefore, for a spontaneous process, Gibbs energy decreases, Gibbs energy change of the system should be negative. Exactly similar case. Thus, we can predict the spontaneity of a process based on the thermodynamic properties of the system. That is, for a finite change, the criteria for spontaneity of a process at constant temperature and pressure is given by del G at constant temperature and pressure less than 0. Now, if that should be del G at constant temperature and pressure should be greater than 0 in case of equilibrium. So, if the system will be in equilibrium, then del G. So, this is for finite. Del G means for finite, and dg means for infinite. Your process will be spontaneous at all temperatures and equilibrium will not be observed. And if del H is greater than 0 and del S is less than 0, the process will be non-spontaneous at all temperature and equilibrium will not be observed. And again, if del H is less than 0 and del S is less than 0, then we have to find out the equilibrium temperature, that is T equals to magnitude of del H by magnitude of del S, and the process will be spontaneous at a temperature lower than T. And if del H is greater than 0 and del S is greater than 0, then also we have to find out the equilibrium temperature T equals to del H by del S, and the process will be spontaneous at temperature higher than the equilibrium temperature. Now, again, if del S equals to 0, then the spontaneity will depend only upon the value of del H, and for spontaneous process, del H should be less than 0. That means the process will be spontaneous only for exothermic processes. And similarly, if del H equals to 0, the spontaneity of a process only depends upon the change in entropy, and if del S will be greater than 0, then the entropy must increases for all the spontaneous processes. So this is one numerical question. In this numerical question, you can see, so both here we have discussed two long questions and two short note. One short note is Clausius inequality, and another short note is combination of first and second law. and here these are the two long questions. So here one numerical question is there for a system undergoing isothermal and isobaric process. Isobaric means constant pressure. In that numerical, isobaric means constant volume. So for a system undergoing isothermal and isobaric process, the change in enthalpy and entropy will be this and this. The process will be, so the question will be like this: whether the process will be spontaneous at 330 Kelvin or not, and calculate the temperature at which the system will attain equilibrium, assuming that enthalpy and entropy changes not affected by the change in temperature. So coming to the answer, the solution, the first one is the process will be spontaneous if del G must be negative. That means del G equals to del S minus T del S. The value of del G should be negative, then the process will be spontaneous. Now the value in the question, the value of del G del H equals to 58 kilojoule per mole, that is 58,000 joule per mole, and the value of del S is given 185 joule Kelvin inverse mole inverse, and the value of T is given 330 Kelvin. So substituting this value in this equation del H minus T del S, we can find out minus 3050 joule per mole. Since the computed value of the Gibbs energy change is negative, the process will be spontaneous. And the system will attain equilibrium in this condition when del G equals to 0. That means magnitude of del H equals to magnitude of T del S. So T E equals to magnitude of del H by magnitude of del S. You will put the values of given value, so the temperature will be 313.51. If the temperature will 313.51 Kelvin, the system will attain equilibrium. But in this question, the temperature is given that is 330 Kelvin. That means more than that condition. That's why the system is in spontaneous process. Now again, similarly, the physical significance of the Gibbs energy. In the physical significance of the Gibbs energy, we can write G equals to H minus Ts, and putting this, and again we can put H equals to U plus PV. So in place of H, we can put U plus PV. So G equals to U plus PV minus Ts. Now the change in Gibbs energy can be written as dg. So if we take derivative of both the equation, dg equals to du, derivative of dpv means pdv plus vdp, and similarly dts means minus tds minus sdt. And again we can recall the first law of mathematical form of the first law of thermodynamics. Here we know that du equals to tds plus dw. So in case so if we put the value of du as a tds plus dw reversible, so here tds and minus tds will be cancelled out. So we can write dg equals to tds plus dw reversible plus pdp plus vdp minus tds minus sdt. So tds will be cancelled out. So we can write dg equal to dw reversible plus pdp plus vdp minus sdt. So at constant temperature and pressure, dt equals to 0, dp equals to 0, because the condition is at constant temperature and pressure. So this term will be vanished, this one will be 0. So that means this term will be 0, and dp vdp, this term will be 0. So we can write dg equals to dw reversible plus pdp. So dw reversible is the total work done on the system under irreversible condition, at constant temperature and pressure. This can include all type of work like mechanical work, electrical or chemical work also. You know that the mechanical work is work of expansion and work of compression, and is given as, if you only consider the mechanical work, dw mechanical equals to minus pdv. Now substituting this value in this equation, we can write dg equal to dw reversible minus dw mechanical. So dw reversible minus dw mechanical is non-expansion work. We can call if the net work done under reversible condition and write dg equal to this one, and hence the work done on the system, so work done by the system is there, that's a negative value is there. So we can write minus dg equals to minus dw. So now coming to the relationship. So here we have discussed about the two functions, that is Gibbs energy and Helmholtz energy. So the Helmholtz energy was used to find out the spontaneity of a process at constant temperature and constant volume. The Gibbs energy was used to find out the spontaneity of the process at constant temperature and constant pressure. So here, if we'll find out the relationship between them, relationship between them, and starting from equation 36, by using again we know that internal energy H equals to U plus PV and G equals to H minus TS. So in place of uh, H, we can write U plus PV minus TS. So, and again from equation 21, we know that A equals to, remember in the previous expression, that is A equals to U minus TS. So in place, so if we rearrange this equation 53, G equals to H minus Ts. Now in place of H, we can write U plus PV. So G equals to U plus PV minus Ts. And again you remember A equals to U minus Ts. So in place of U minus Ts, we can write A. So G equals to A plus PV. And let the initial state of the system, the value of the Gibbs energy will be G1, the value of Helmholtz energy A1, pressure P1, volume V1, temperature T1. And in the final state, the value of Gibbs energy G2, Helmholtz energy A2, pressure P2, volume V2, and temperature T2. So we can rearrange G1 equal to A1 plus P1 V1 and G2 equal to A2 plus P2 V2. Then the change in Gibbs energy will be given by this following expression, that is G2 minus G1 equals to A2 minus A1 plus P2 V2 minus P1 V1. So that is del G equals to del A plus P2 V2 minus P1 V1. And again, from the ideal gas equation, we know that PV equals to nRT. So P2 V2 equals to nRT2, P1 V1 equals to nRT1. Now putting this value, we can write del G equals to del A plus nRT2 minus T1. So if as if the temperature is kept constant during the change, that is T2 equal to T1, we can write del G equals to del A. So this is the relationship. Predict whether the system will be spontaneous or non-spontaneous from the following cases at 300 Kelvin. Then what you have to do? So here the question is there. Predict the process will be spontaneous or non-spontaneous. Here the value of del U is given, del S is given, and the temperature is given. You have to find out del A equals to del U minus T del S. So if the value of del A will be negative, the process will be spontaneous. If the value of del A will be 0, the process will be equilibrium. And if the value of del A will be positive, the process will be non-spontaneous. So like you can find out the values. And similarly, another question is there. So in this, the change in internal energy of a system undergoing isothermal process at constant volume was found to be this, and entropy change was found to be this. Calculate the temperature at which the system will attain equilibrium, assuming that internal energy and entropy change do not vary with temperature. So this is one direct question you can easily solve. And the another one is that is the next question. Based on the given value of del H and del S, predict one of the following process will be spontaneous at 300 Kelvin or not. Similarly, here del H value is there, T value is there, del S value is there. You will find out del H minus T del S equals to del G. You have to find out the value of del G. If the value of del G will be negative, that is spontaneous. If the value of del G will be 0, that is equilibrium. If the value of del G will be positive, that is non-spontaneous. Now coming to the properties of Gibbs energy and Helmholtz energy. So here just wait for 5 minutes, and after that we'll again continue. 2-3 minutes, just wait for 2-3 minutes.
Hello, sir.
Hello.
हेलो सर.
Hello.
हाँ सर, आपका नंबर मिल सकता है क्या, थोड़ा मतलब जानकारी के लिए, कुछ डाउट के लिए.
Okay, so you just WhatsApp me. So don't call me. So if you have any problem, you will WhatsApp me. So when my time will be there, I can answer that. Okay.
सर आपका नंबर सर.
Okay. So my number is 94378
यस सर, देन.
91535. 94378 91535.
यस सर, थैंक यू सर.
Okay. So just wait 2-3 minutes. After that, again we'll continue.
Sir, can you please repeat the number?
The number is 94378
8
91535.
5 3. Thank you, sir.
Okay. So here we will continue. So this one is the temperature and pressure dependence of Gibbs energy. We have already discussed that Gibbs energy G equals to this one G. Here we have discussed one new function that is called Gibbs energy, which is applicable for the to find out the criteria of spontaneous process at constant temperature and constant pressure, and G equals to H minus Ts. So here we can put the values. So the system, if the system at a temperature different from the standard state, that we need to consider the temperature dependence of G to get the required data. Again, if we have a system at a temperature difference from the standard state, then we need to consider the temperature dependence of G to get the required data. In other words, how does the Gibbs energy of a system changes on changing the temperature or pressure? We will consider the two possibilities. First one is variation of Gibbs energy with temperature at constant pressure. If the pressure will be constant and if the value of temperature will change, how the value of Gibbs energy will change. And similarly, the second one, variation of Gibbs energy with pressure at constant temperature. So these are two different things, two different short questions may come. So let us consider a system undergoing a reversible pressure volume change. So from this we can write G equals to U plus PV minus Ts, because G equals to H minus Ts. We have already discussed G equals to H minus Ts. In place of H we can write U plus PV. So G equals to U plus PV minus Ts. Now taking differential both sides of this equation, we can write dG equals to du plus PdV plus VdP plus PdV plus VdP minus TdS minus SdT, because we are taking differential both sides. For a reversible pressure volume change, we can write du equal to TdS minus PdV. So in place of du, we can write TdS minus PdV. So the value of dG equal to TdS minus PdV plus PdV plus VdP minus TdS minus SdT. So here you can see PdV will be cancelled, TdS minus TdS will be cancelled, and the value of dG will be equals to minus SdT plus VdP. Thus, we can say that for a system undergoing reversible pressure volume change, the Gibbs energy change depends upon the temperature and pressure, and this can be expressed as G equals to a function of temperature and pressure, and dG equals to del G by del T at constant pressure dt. Taking differential form, we can write dG equals to, so this is the partial derivative form. So here G is a function of temperature and pressure. That's why dG equals to partial derivative, in partial derivative form, dG equals to del G by del T at constant pressure dt plus del G by del P at constant temperature dP. And here, and again, if you compare this equation with this one, because we know that in the from the previous section we know that du dg equals to dw plus pdv, this one. Because in the previous section we have discussed that dg equals to minus sdt plus vdp. Again, from the previous section we have somewhere we have discussed that dg equals to, we have discussed that dg equals to section. Now if we compare both this equation, we can write del G by del P, del G by del T at constant pressure equals to minus S, and del G by del P at constant temperature equals to nothing but volume. Now coming to the next expression, that is variation of Gibbs energy with temperature at constant pressure. variation of Gibbs energy with temperature at constant pressure, that is called Gibbs-Helmholtz equation. Again, I am telling variation of Gibbs energy with temperature at constant pressure, that is called Gibbs-Helmholtz equation. Now this equation 69, this one, so this is the partial derivative form equation, that is dg equals to del g by del t at constant pressure dt plus del g by del p at constant temperature dp. This is equation 69. So the equation 69 gives the total change in Gibbs energy when the temperature and pressure. So from this equation, we will find out the change in Gibbs energy when temperature changes at constant pressure and the change in Gibbs energy when pressure changes at constant temperature. From this equation, we will find out both the conditions. So the first one, variation of Gibbs energy with temperature at constant pressure, that is called Gibbs-Helmholtz equation. So from this equation, we can find out the total change in Gibbs energy when the temperature and pressure changes by dt and dp respectively. So here the change in temperature is dt and change in pressure is dp. However, it is always easier to study the variation of thermodynamic properties with change in only one parameter. So in this equation, two parameters are changed, that is dt and dp. But it will be easier if we'll find out the variation of the change in Gibbs energy value when only one parameter will change. Only one parameter will change means first we will discuss the variation of Gibbs energy with temperature at constant pressure. That means dp will be 0. So when dp will be 0, this term will be 0 and the value of dg will be del g by del t at constant pressure dt only, and this one is minus s. So we can write when at constant pressure, we can write del g at dg equals to minus s dt. Second term will be 0 because at constant pressure means dp will be 0. Now, to find out the total change in Gibbs energy with change in temperature, we have to integrate the above. So this is the differential form. But if we want to find out the total change in Gibbs energy in a finite chain, we have to take integration of this equation 71. By taking this integration of this equation 71 both sides, with finite value, that is the Gibbs energy value changes from G1 to G2 and the temperature value changes from T1 to T2. So here integrating this equation both sides, we can write like this: as entropy is temperature dependent, it can be taken inside the integral. So entropy is not constant, that is temperature dependent. So we have to put inside the integral. And the LHS of this integral will be like this: G2 minus G1 equals to minus of integration of S dt from T1 to T2. Since entropy increases with increase in temperature, the right hand side of the above expression will be always less than 0 as the value of the entropy increases. So since entropy increases with increase in temperature, so the right hand side will be always less than 0 because negative sign is there. If negative sign will be not there, then the right hand side is always greater than 0. But as the negative sign is there, the right hand side will be always less than 0. Therefore, we can say that Gibbs energy decreases with increase in temperature. That means if temperature increases, the Gibbs energy decreases. So this is equation 73. Now using 36 and 70. So this one is equation 70, this one. So using 36 and 70, we can write G equals to H minus Ts, H plus Ts, H minus Ts. Now in place of H minus Ts, in place of minus S, we can put dg del g by del t at constant pressure. So putting these values, we can write G equals to H plus T because we know that G equals to H minus Ts. Again, from equation 70, we know that minus S means this one, del G by del T at constant pressure. So we can write G equals to H plus T del G by del T at constant pressure. Now rearranging this, we can write H equals to G minus T whole into del G by del T at constant pressure. Now dividing equation 75 throughout T square, we can write H by T square equals to G minus T del G by del T at constant pressure divided by T square. Thus, to simplifying the above expression, we take the function G minus T, G by T and differentiate it. If we take G by T as a single function and differentiate it, so del G by T differentiate with respect to temperature at constant pressure. So del G by T with respect to, that is del G by T by del T at constant pressure is nothing but H by T square. And this one is the right hand side. So in the right hand side, we can write T whole into del G by del T at constant pressure equals to minus G by T square. So now combining both these equations, we can write del G by T by del T at constant pressure equals to minus H by T square. This equation is nothing but, that is called Gibbs-Elmore equation. This is very important one. Derivation of Gibbs-Elmore equation is the most probable question for the semester examination. Now coming to the next one, variation of Gibbs energy with pressure at constant temperature. The previous one was the previous derivation was like this: variation of Gibbs energy with temperature at constant pressure, but here that is variation of Gibbs energy with pressure at constant temperature. Now again from the equation 70, the change in Gibbs energy with pressure at constant temperature was given like this: del G by del P at constant temperature equals to V. This one from equation 70. This one del G by del P at constant temperature equals to V. Only we are taking the equation 70 here. Therefore, we can write del G equals to del G at constant temperature equals to VdP. Now taking integration in both sides of this equation, we can write integration of dG from G1 to G2 equals to integration of VdP from P1 to P2. And the LHS of this equation will be G2 minus G1, and the RHS will be, because volume is constant, so it can be taken outside of the integral, so V P2 minus P1. And again, we know that V equals to, from the ideal gas equation, we know that V equals to nRT by P. Now putting these values, we can write G2 minus G1 equals to integration of P1 to P2 nRT by P. In place of V, we are writing nRT by P. So G2 minus G1 equals to integration of nRT by P dP from P1 to P2. Now nRT will be constant, and that can be taken outside of this integral. So we can write it, the RHS of this equation like this: integration of dP by P from P1 to P2, and the integration of 1 by x dx will be ln x, and similarly the integration of 1 by P dP will be ln P, and here limit value is there P1 to P2. So we can write nRT ln P2 by P1. As the pressure is increased, then P2 is greater than P1, and the right hand side, and the RHS of this above equation will be greater than 0. Hence, ideal gas, for ideal gas, as the Gibbs energy increases with increase in pressure, we know that for an ideal gas under condition P2 V2 equals to P1 V1. So instead of writing nRT ln P2 by P1, we can also write nRT ln V1 by V2. So this is one numerical question is there. So that is one direct question. You can find 1 mole of an ideal gas undergoes isothermal expansion from 10 liter to 100 liter at 300 Kelvin. Calculate the change in Gibbs energy in the process. From this equation, we know that del G equals to nRT ln V1 by V2, which is equals to nRT ln P2 by P1. But here, according to this equation, V1 by V2 equation will be used. So that is equals to, so here the natural logarithm ln form, natural logarithm form will be converted into logarithm base 10. So that will so then 2.303 will be multiplied. So nRT ln V1 by V2 equals to 2.303 nRT ln V1 by V2. So here in this question, the given condition N equals to 1 mole, R is nothing but the universal gas constant, T equals to 300 degree, 300 Kelvin that is given in this equation, V1 equals to 10 liter, V2 equals to 100 liter. By putting all these values, we can find out the value of del G equals to minus 5744.14 joule. And the change in Gibbs free energy for this process will be like this, minus 5.744 kilojoule. Similarly, these two equations you can easily solve. Now coming to temperature dependence of volume, temperature and volume dependence of Helmholtz energy. In the previous section, we have discussed about the temperature and pressure dependence of Gibbs energy. Temperature and pressure dependence of Gibbs energy. Exact similar derivation will be there. Exact similar derivation will be there. That is temperature and volume dependence of Helmholtz energy. So initially, in order to derive that one, two conditions are there. First one is variation of Helmholtz energy with temperature at constant volume, and the second condition is variation of Helmholtz energy with volume at constant temperature. And again, from the starting, we have already studied A equals to U minus Ts, then dA equals to du minus Tds minus SdT. For a reversible pressure volume change, again we know that du equals to Tds minus Vdp, that is from first law of thermodynamics. So putting this values of du here, we can write dA equals to Tds minus Vdp, Tds minus Vdp minus Tds minus SdT. So Tds will be cancelled out. So dA equals to minus SdT minus Vdp. And here you can see that Helmholtz energy is a function of temperature and volume. So if we take the differential form, then del A equals to partial derivative term dA equals to del A by del T at constant volume dt plus del A by del V at constant volume dV. And again, if we compare this equation, we can find out this equation to this one, dA equals to minus SdT minus Vdp. We can find out this term is nothing but minus S, and this term is nothing but minus P. Now coming to the first case, variation of Helmholtz energy with temperature and constant volume, that is Gibbs-Helmholtz equation. So this is another form of Gibbs-Helmholtz equation, exactly similar case, only del G was there, here dA is all these derivations you can easily find out that one exactly similar cases. So this is another form of the Gibbs-Helmholtz equation. So in the question it will come like this: derive the Gibbs-Helmholtz equation in terms of Gibbs energy and derive the Gibbs-Helmholtz equation in terms of Helmholtz energy. So if you will derive the Gibbs Helmholtz equation in terms of Gibbs energy, the equation in place of A you have to write G, and here in place of U you have to write H. And if you derive the Gibbs-Helmholtz equation in terms of Helmholtz energy, so this is the equation. And now coming to the variation of Helmholtz energy with volume at constant temperature. See, exactly similar type of derivation is there. Whatever we have discussed in Gibbs free energy, exactly similar type of derivation. Now coming to the next one is Maxwell relationship. So this one we will discuss tomorrow. Hello?
Okay, sir.
From this onwards, we will discuss tomorrow. So all of you, you have to you go through what we have studied today. So you go through the study material, and if you will face any problem or if you will have any doubt, then tomorrow we will discuss. Okay.
Sure,
Okay,
sir.
sir.
Okay, sir. Question, if I may, sir.
Sorry. Hello.
Hello, sir. Sir, just one question, if it is okay. May I ask one question?
Yes. Yes.
Sir, when is the last date for assignment submission, and when are the exams for semester 1, sir?
So you belong to which study center?
Bhubaneswar, sir.
Sorry, actually, notification is not there.
So I think I missed it. I'm not sure. So if there is any
Yes,
way I
sir.
can
The
reach.
notification has been given. It is 30th September, the last date. Before.
Yes, September is for the assignment, is it?
Yes.
So I think it is extended. So
Okay. Okay. Thank you, sir. Yeah, if you can please let me know,
Hello.
I'll try to finish submit.
Hello.
Hello. Yes.
yes, hello.
Sir, I just wish to ask, is this practical class for this batch is over?
No, no, no.
Okay,
So
sir.
practical class will be there. So we'll discuss.
Is it offline, sir?
Major of
Practical
the
class.
practical class will be in the online, and after that
Acha.
only few things will do in the offline. But major practical class will be online class.
And sir, how these questions means how will be the questions kind of like, is there any previous year setup means solved version or something? Is it available?
For the practical or theory?
For theory, like for exam, when we will be writing. So for that, something solved question paper so that it will be easy to prepare.
Solve question papers are there. You can find out. No problem. You ask to your study center or from the regional center. You can find.
Sir,
You can.
where we can find this question paper?
Otherwise, I can provide the previous question paper for this paper only. Okay.
Okay, okay. Thank you so much. Sir.
Okay.
Thanks.
हेलो सर.
Yes.
हेलो सर.
Hello.
हाँ सर, मैं ये बोल रहा था कि हमारे जो अभी आप जो क्लास ले रहे हैं ना, उस
जी.
सब्जेक्ट का थोड़ा मतलब एक व्हाट्सएप ग्रुप बना देते तो थोड़ा आसान होता सर. मतलब
Okay, you can do that one. No problem. So you can do the WhatsApp group. No problem. Okay.
ये सर.
So if you all of you join, and you can also add my number. No problem. Okay. So rest thing will continue from tomorrow.
Okay, sir.
Sir, thank you, sir.
Okay.
Thank you,
Thank you,
sir.
sir.
Okay.
So who is going to form the group? Hello.
हेलो.
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 Yes, hello.
Hello. Hello.
हाँ, कोई बता सकता है कि इस बार मतलब कितना असाइनमेंट सबमिशन करना है, कौन सा सब्जेक्ट का?
वही तो कंफ्यूजन है अभी, क्या 8 सब्जेक्ट का करना है या फिर 4 सब्जेक्ट का करना है, वो तो
Nine.
कंफ्यूजन है.
ऑनलाइन तो मतलब अभी हमारा जो प्रोग्राम है ऑनलाइन में 5 दिखा रहा है, जो कि उसमें एक MCH-11 है, जो कि जून 2025 को सबमिशन था. बाकी
Actually,
4 अभी दिखा रहा है.
hello.
हाँ बोलो.
हाँ.
Actually, असाइनमेंट जितना एग्जाम देना है आपको उतना असाइनमेंट सबमिट करना पड़ता है. सपोज आप सेमेस्टर का जितना भी सेमेस्टर 1 का जितना पेपर्स देंगे तो उतना असाइनमेंट सबमिट करेंगे.
ठीक है, अभी तो असाइनमेंट 5 ही असाइनमेंट शो कर रहा है ऑनलाइन में.
हाँ.
ऑनलाइन में 5 दिखा रहा है, बाकी एक MCH-11 है, जो कि जून 2025 को सबमिशन लास्ट डेट था, तो वो स्किप हो गया ना. बाकी 4 है अभी.
अभी जितना तक मुझे याद है वो असाइनमेंट आई थिंक सितंबर लास्ट और इन मंथ ऑफ अक्टूबर विल सबमिट.
हाँ. अरे मैंने तो सेंटर
नहीं
कोऑर्डिनेटर से
ऑनलाइन जो आप
मैसेज किया
बता
था.
रहे हैं ना, जो कि 5 दिखा रहे हैं, वहाँ पे दिसंबर लास्ट दिखा रहा है सबमिशन लास्ट डेट।
हाँ
हाँ,
वही।
वो तो दिसंबर लास्ट दिखा रहा है अभी।
तो ये लास्ट ईयर जो स्टूडेंट थे वो अक्टूबर में सबमिट किए थे एक्चुअली।
हाँ, हमको भी पहले अक्टूबर दिखा रहा था, लेकिन अभी मैंने देख रहा था 2 दिन पहले वो दिसंबर दिखा रहा है।
हाँ
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 वही तो बात है, 2 दिन नहीं मतलब काफी एक हफ्ता हो गया वो
हाँ,
दिसंबर
मैंने
दिखा रहा
देखा
है।
2 दिन बाद, मैंने देखा तो कहाँ
हाँ
से अपडेट हुआ मुझे पता नहीं, मैंने देखा।
किस टाइप का असाइनमेंट सबमिट करना हो, हमको तो कोई नोटिफिकेशन ही नहीं है।
नहीं नहीं, कुछ भी नोटिफिकेशन नहीं आया ऐसा कोई सबमिशन के लिए।
हाँ,
अच्छा सुनिए, हमारा जो ग्रुप फॉर्मेशन हुआ था पहले से, ठीक है।
कौन सा ग्रुप भाई, मुझे तो नहीं पता कौन सा ग्रुप है भाई।
एक ग्रुप है ना, ग्रुप हम फॉर्म किए थे, जो इंडक्शन मीटिंग हुआ था, फर्स्ट इंडक्शन मीटिंग हुआ था एडमिशन के बाद।
हाँ, वो तो मीटिंग तो हुआ था, वो ज्वाइन भी मैंने हुई थी, लेकिन ग्रुप वगैरह कुछ तो मैंने ज्वाइन भी नहीं हुई।
बाय मिस्टेक आपका नंबर नहीं होगा मेरे साथ, मैंने फॉर्म किया था जहाँ पे 30-40 लोग हैं यहाँ।
और तो भाई वहां पर मुझे ज्वाइन कर दीजिए।
हाँ मैं ज्वाइन करवा दूंगा। आपका नंबर थोड़ा बोलिए तो।
लिख रहे 760।
वो चैटिंग पर सर ने दे दिए, मैसेज पर सर दे दिए, अब वहां से लेके ज्वाइन करवा दीजिए सबको।
ये देखो भाई, मैंने लिख दिया ग्रुप में, मैसेज सेक्शन में लिख लिया, देखो रश्मि रंजन मोहरी दिखा रहा होगा,
हाँ हाँ
वही
सर
नंबर है।
मुझे भी ऐड कर लीजिए।
जस्ट सेकंड जस्ट।
भाई मुझे भी
मैंने
ऐड
भी
कर
अभी
दो।
और एक बात,
हेलो,
हमारा
मैंने
सेमिस्टर
भी अभी
1
मेरा
दिसंबर में।
नंबर शेयर किया है, बाकी कोई व्हाट्सएप ग्रुप थोड़ा बना लो।
जो भी है वहां पर ये सब नंबर ऐड कर लो,
हाँ
डिस्कशन
मैं
मेरा
ऐड
ग्रुप
नाम
भी
करवा
आता
सौम्य
है।
है।
आप मैसेज कर दीजिए, मैं सारे को
नहीं
ऐड
नहीं,
करता
कोई
हूँ।
एक ही रेस्पॉन्सिबिलिटी लो, बाकी मतलब इतना सारा नहीं, मैं ये बोल रहा था।
हाँ हाँ ठीक है, एक ही ग्रुप बनाओ, इसमें सबको ऐड कर दो।
हाँ मैं ऐड करवा दूंगा, ओनली आप नंबर दे दीजिए।
दे दिया ना मैंने, यहाँ पर
हाँ
दे
हाँ
दिया।
हाँ भाई, थैंक यू।
अपने मैसेज स्क्रीनशॉट ले लीजिए सभी का नंबर का।
यस यस यस।
और भाई एक डाउट है, ये जो हमारा दिसंबर में बोल रहे हैं कि सेमिस्टर 1 होगा, तो हमने जनवरी में एडमिशन लिया था, दिसंबर में सेमिस्टर 1 होगा, तो
हाँ
कितने साल में ये खत्म होगा हमारा ये
दो
एक्चुअली
साल
कितने
ये
साल में?
2 साल का प्रोग्राम है, लेकिन मैक्सिमम 4 साल में आपको ये प्रोग्राम खत्म कर देगा।
और मैक्सिमम मतलब वो जो स्किप करेगा उनके लिए मैक्सिमम
हाँ
4 साल
हाँ
लगेगा,
हाँ
हम तो स्किप नहीं
यस।
कर रहे हैं ना, हम तो
हाँ
डायरेक्ट
ना
एग्जाम देने चाहते हैं, तो ये
हाँ हाँ।
फर्स्ट सेमिस्टर दिसंबर में कैसे होगा?
ये ब्रो, हाँ
ये
लास्ट जो है ना थोड़ा लेट होता है, उसके बाद वो टाइम में आ
ये
जाता
देखो यहाँ पर, ये देखो मैसेज सेक्शन में प्रियंका सेंडर नाम के कोई लिखा है कि दिसंबर में बोथ सेमिस्टर 1 और 2 विल बी एग्जाम विल बी कंडक्टेड, 2 एग्जाम कंडक्ट होगा दिसंबर में।
है। नहीं, ऐसे कैसे कर सकते हैं?
हाँ ऐसा ही होगा, मुझे लगता है
हाँ
ऐसा ही होगा
ऐसा
कि
ही है,
8।
मतलब 2
हाँ ऐसा
सेमेस्टर
ही होगा,
लेंगे
नहीं तो
दोनों के
तो
दोनों
नहीं हो
सेमेस्टर
पाएगा।
एक ही साल में।
दिसंबर में।
हाँ एक ही साल में होगा, एनुअल मोड मतलब ऐसा ही
एक
होता
ही
है।
साल में 2 सेमेस्टर का एग्जाम होगा।
हाँ
हाँ
ये
4
आठ
साल
आठ
बाद
पेपर
सेमेस्टर 3 और सेमेस्टर 4 का।
एक्चुअली एक्चुअली
हाँ
प्रॉब्लम क्या
8
होता है
पेपर का होगा।
ना, एक्चुअली 1 ईयर में पहले से क्या होता था ना, टर्म फर्स्ट टर्म होता था, सेकंड टर्म, टर्म 1 टर्म 2। लेकिन इस
हाँ
साल 1 ईयर में सारे पेपर देना पड़ेगा एट द एंड ऑफ द ईयर।
हाँ वही 8 पेपर देना पड़ेगा एक साल में, दिसंबर में 8
यस यस
पेपर देना पड़ेगा।
यस।
और जो एक बात है, वो जो मैथमेटिक्स और बायोलॉजी, वो दोनों तो
आगे बढ़ा रहे हैं।
है ना, इलेक्टिव है ना, दोनों के लिए अलग अलग जो भी चूज कर
हाँ
सकते हैं।
दोनों effective है, वो अपना अपना चॉइस में रखेंगे।
ठीक है ठीक है।
अच्छा, ये हेलो,
कोई बोल रहा था कि
आगे
एक
बढ़ा रहे थे।
नोटिफिकेशन आया था सबमिशन के लिए।
नहीं नहीं, कुछ भी नोटिफिकेशन नहीं है, कुछ भी नहीं है।
नोटिफिकेशन
नोटिफिकेशन कोई नहीं है।
जो भी जून में जो एग्जाम हुआ है ना, वो मैं पूछ रहा था सेंट्रल कोऑर्डिनेटर से, वो बोल रहे हैं कि जो जुलाई 2024 में जो एडमिशन किए थे उनका एग्जाम है, वो हमारा नहीं है, मैंने मैसेज किया था उनको।
एक्चुअली जो प्रैक्टिकल एग्जाम
अच्छा।
ना, ठीक है,
हम्म
प्रैक्टिकल एग्जाम हमारा यहीं पे
हाँ
हो रहा है, रीजनल सेंटर पे कर रहे हैं वो लोग।
नहीं नहीं,
हाँ
अभी
तो
हमें जो अभी क्लास
अभी
अटेंड कर रहे
हमारा
हैं
कुछ
ना,
भी नहीं हुआ है,
कोई
हमारा कुछ
रीजनल
भुवनेश्वर
भुवनेश्वर।
स्टडी
हाँ
सेंटर से है, कोई
भुवनेश्वर।
केंद्रापड़ा स्टडी सेंटर से है।
नहीं मेरा
केमिस्ट्री का तो एक ही स्टडी सेंटर है ना केंद्रापड़ा, भुवनेश्वर तो नहीं है ना, भुवनेश्वर में तो कोई स्टडी सेंटर नहीं है केमिस्ट्री का।
हाँ नहीं, सारा अभी पूछ रहे
हाँ
थे स्टडी सेंटर कौन सा है, कोई भुवनेश्वर बताया, जो कि
नहीं
रीजनल
नहीं
सेंटर
नहीं
होता
नहीं,
है वो।
वो गलत
नहीं नहीं,
बताया, वो
अभी
गलत
पोर्ट हो
बताया,
सकता है
भुवनेश्वर नहीं।
शायद।
नहीं
भुवनेश्वर,
सुनिए
केंद्रापड़ा
मेरा
से भुवनेश्वर होगा।
1 मिनट।
अच्छा।
मेरा एक स्टूडेंट है जो लास्ट ईयर का है, अभी एमएस कर रहा है, वो इसका प्रैक्टिकल एग्जाम रीजनल सेंटर में दिया है।
हेलो।
हाँ हेलो।
हाँ, मैंने बोला जो
हाँ
मेरा एक दोस्त है जो लास्ट ईयर का एडमिशन लिया था एमएससी का, वो
हाँ
इस बार प्रैक्टिकल एग्जाम रीजनल सेंटर भुवनेश्वर में दिया है वो।
हाँ
तो
हाँ,
प्रैक्टिकल
भुवनेश्वर
एग्जाम
में
में
देते
भी
हैं।
भुवनेश्वर में हो सकता है, मे भी।
हाँ, वही
हाँ,
में
ना आपको
और
सेंटर
बाकी
चूज करने का
असाइनमेंट
ऑप्शन दिया
सबमिशन के
होगा।
लिए कहाँ जाना पड़ेगा?
नो आइडिया, वो बोल रहे थे ऐसे 2 घंटा भाई भी हो रहा है।
हाँ,
नहीं, असाइनमेंट सबमिशन के लिए जाना पड़ेगा या फिर पोस्टल से भेजना
ना,
पड़ेगा?
आइदर स्पीड पोस्ट और डायरेक्ट हैंड में सबमिट हो सकता है।
डायरेक्ट हैंडल सबमिट में
अच्छा,
बेटर होगा। ओके।
हाँ, डायरेक्ट सबमिशन।
मतलब जाना पड़ेगा वहाँ पे।
हाँ,
हाँ हाँ, जाना पड़ेगा। जाके दोगे तो अच्छा होगा, वहाँ पर ठीक लगेगा तुमको। ये
बाकी
स्पीड पोस्ट वगैरह
सब
ये।
कल में कौन, मतलब सभी लोग उड़ीसा से बिलोंग करते होंगे?
हाँ।
आप जाके देंगे तो आपको रिसीट
तारा
मिलेगा
हिले
तो
कहीं को था जोड़े रहो था वो। ठीक अच्छे भाई किए ग्रुप बनाउछ?
अरे नहीं ମୁଁ କହୁଥିଲି
ଟିକେ
ମାନେ
ଗ୍ରୁପ ରେ କ୍ରିଏଟ କରିକି ନା मेसेज करो ग्रुप क्रिएटेड बोली।
हाँ, ମୁଁ ଆଡ୍ କରିଦଉଛି ବ୍ୟସ୍ତ ନାହିଁ।
हाँ हाँ।
ହେଲେ ଆମେ ଓଡିଆରେ କେତେବେଳେ ଯାଏ
ଆଉ ବାକି କିଏ ଟିକେ ଯଦି ମାନେ ଆସାଇନମେଣ୍ଟ ସବୁ ବନଉଛ ଆଉ ଟିକେ ପିଡିଏଫ ଗୁଡାକ ଟିକେ ଛାଡିବ, ବାକି ସମସ୍ତଙ୍କ ପାଇଁ ଟିକେ ହେଲ୍ପଫୁଲ ହବ।
ଆକ୍ଚୁଆଲି
ନାଇଁ କି?
ଆସାଇନମେଣ୍ଟ
ସବୁ
ଗୁଡା ମ୍ୟାକ୍ସିମମ୍ ପିଲା କିଣି ଦଉଛନ୍ତି, ହେଲା କି? ହ୍ୟାଣ୍ଡ ରିଟନ ଆସାଇନମେଣ୍ଟ ମ୍ୟାକ୍ସିମମ୍ ପିଲା କିଣି
ନାଇଁ
ଦଉଛନ୍ତି।
ତମମାନଙ୍କର କଣ ମାନେ ଇଏ, ତମମାନେ ସବୁ କିଣୁଛ ନା ବନଉଛ ନିଜେ ଲେଖୁଛ?
ମୁଁ ତ ଏପର୍ଯ୍ୟନ୍ତ ବନେଇ ନାହିଁ, କିନ୍ତୁ କିଣିବି ବୋଲି ଆଡ କରି ରଖିଛି।
ଆଚ୍ଛା,
ସମସ୍ତଙ୍କୁ ତ
ଭାଇ
ଅନଲାଇନ
ମାନେ
ରେ
ଯିଏ ଟିକେ
ମାନେ
ଆନ୍ସର
ଯେମିତି ହେଲେ
ପାଇବେ ଟିକେ
ହ୍ୱାଟ୍ସଆପ ରେ।
ଦେବେ।
ମୁଁ ଅଲରେଡି ଗୋଟେ ଛାଡ଼ିଦେଲିଣି, ମାନେ ମୁଁ ହଠାତ୍ ଦେଖିଲି ନା ସେପ୍ଟେମ୍ବର ବୋଲି, ମୁଁ ଗୋଟେ ହଠାତ୍ ଇଏ କରିଦେଲି। ବାକି ମୁଁ ଡାଉଟ ରେ ଅଛି 4ଟା କରିବି ନା 8ଟା କରିବି ସବମିଶନ।
ଉପରେ
ଫର୍ମ ଫିଲଅପ ଯେତେଟା କରିବ ସେତେଟା
ବହୁତ ମୁଣ୍ଡ କଥା ମାନେ assignment ଗୁଡା। ଠିକ ଅଛି, ହ୍ୱାଟ୍ସଆପ ଗ୍ରୁପ ପଠାଅ ତାପରେ ଇଏ କର।
ହଁ
ଭାଇ
ଲିଙ୍କ
ଫର୍ମ
ଛଡା
ଫିଲଅପ କେବେ?
ହେଇଯିବ।
ହ୍ୟାଲୋ।
ହଁ ଫର୍ମ ଫିଲଅପ କେବେ?
ହ୍ୟାଲୋ।
ହ୍ୟାଲୋ।
ହଁ କହ।
ଆସାଇନମେଣ୍ଟ ସବମିଟ ପରେ ଫର୍ମ ଫିଲଅପ ହବ ନା ତା ପୂର୍ବରୁ?
ନା
ନା
ଆସାଇନମେଣ୍ଟ
ଆସାଇନମେଣ୍ଟ ସବମିଟ ସରିଲା ପରେ ପରେ ବୋଧେ।
ଫର୍ମ ଫିଲଅପ ହବ।
ଭାଇ
ଫର୍ମ
ଯୋଉ
ଫିଲଅପ
ଇଏ ହ୍ୱାଟ୍ସଆପ ର ମୁଁ କହିଲି
ଫର୍ମ
ଗ୍ରୁପ ର ଯୋଉ ପଠେଇଛ ସେଇଥିରେ ତ ମାନେ ସେଇ ଗ୍ରୁପ ରେ ତ?
ମୁଁ ଏବେ ପଠଉଛି ସାଙ୍ଗେ ସାଙ୍ଗେ ନମ୍ବର ଗୁଡା ସବୁ କଲେକ୍ଟ କରୁଛି। ମୁଁ
ନା
କରିକି
ନା
ଆଡ୍ କରୁଛି।
ହ୍ୱାଟ୍ସଆପ ରେ କିଏ ଗୋଟେ ପଠେଇଛି ମାନେ ଇଏଟା ଗ୍ରୁପ ର
ଦେଖ
ଲିଙ୍କ
ତାହେଲେ ଗ୍ରୁପ ମେ ବି
ଟା।
ହେଇଥିବ। ହଁ, ଏଠି ପିଲା
ଗ୍ରୁପ
ଜଏନ
ନା,
କଲେଣି।
ହଁ ଗ୍ରୁପ ନାଁ ହଉଛି କେମିଷ୍ଟ୍ରି ଜୁଏଲ୍ସ।
हाँ हाँ, केमिस्ट्री ड्रिल।
हाँ
हाँ, केमिस्ट्री इग्नू।
पे मुझे कोई समझ में नहीं आ रहा है।
से ग्रुप टाइप में मेसेज कर देले पिला जॉइन करी आंदे कौन किसी आइडिया होगा की?
कौन कहलो?
ଗ୍ରୁପ ଲିଙ୍କ
ମୁଁ ଏବେ
ସେୟାର ଦ
ହାଇଲାଇଟ
ଗ୍ରୁପ
ପଠେଇଲି।
ଲିଙ୍କ।
हम कहली मोते तो टेक्निकल कहीं आइडिया आसुनी एबे आमे जते अच्छे जो माने जॉइन करी नांती
हाँ
ए इनवाइट लिंक टा केमिति कोन पके देले बे हमरो मेसेज
लिंक
स्टार्टिंग।
पठा ही जीवा व्हाट्सएप रे लिंक है। जो कोई भी
अच्छा
ज्वाइन
अच्छा।
करना चाहता है वो व्हाट्सएप का लिंक
हाँ हाँ
हेलो।
हेलो।
हाँ
हेलो।
हेलो।
कोई क्या ग्रुप करना है?
क्या क्या
हेलो।
क्या?
व्हाट्सएप ग्रुप
हाँ,
हाँ
व्हाट्सएप ग्रुप
व्हाट्सएप
किसी
ग्रुप
ने
का
है
लिंक
ऑलरेडी।
भेजा हुआ है। हेलो।
किसी ने भी व्हाट्सएप ग्रुप पे मींस इनवाइट ऐड हुआ है?
हाँ हाँ, व्हाट्सएप ग्रुप का लिंक यहाँ पे मैसेज पे छोड़ दिया है।
मुझे अभी तक भी नहीं आया है कुछ इनविटेशन।
आप मैसेज करो ना गूगल मीट का।
मैं मैसेज में
अभी जो कॉल चल रहा है ना
अपना
गूगल मीट पे, आपका नंबर मैसेज करो तो लोग मतलब ऐड कर देंगे।
ना नहीं नहीं,
मेरा
आप
नंबर
मैसेज
मैंने
करो, इन कॉल
मैसेज कर
मैसेज।
दिया है।
हेलो।
अभी
आप
भी
इन
कोई
कॉल मैसेज करो। इन कॉल मैसेज जहाँ पे मैंने मीट हो रहा है हमारा।
हाँ हाँ, वहाँ पे मैंने मैसेज कर दिया है। अभी की क्या कोई
मैसेज
व्हाट्सएप
नहीं,
ग्रुप?
मैसेज नहीं, वहाँ पे लिंक छोड़ा गया है, आप लिंक पे क्लिक करके आ जाइए ग्रुप में।
ओके ओके,
देखिए मैसेज में छोड़ा हुआ है।
अच्छा ठीक है ठीक है।
ध्रुवचंद प्रधान छोड़े हैं।
और एक बात, यहाँ पे असाइनमेंट का डेट है 30 सितंबर।
वो
तो
13 सेटर है अभी, वो एक्सटेंड होता रहता है। अभी अक्टूबर
वो
होता है
एक्सटेंड
फिर
होता रहता है। अभी तो क्लास स्टार्ट हुआ है, अभी फर्स्ट सेमेस्टर और सेकंड सेमेस्टर दोनों का एग्जाम एक साथ होगा।
हाँ
नो नो
दिसंबर
नो
में
नो
होगा। हाँ भाई।
नहीं नहीं, अभी ऑनलाइन में क्या दिखा रहा है, कौन सा डेट दिखा रहा है सबमिशन के लिए?
ना असाइनमेंट तो एक ही साथ होगा, सितंबर लास्ट की अक्टूबर फर्स्ट में। मगर एग्जाम होगा दिसंबर में शायद।
हाँ, एग्जाम वही दिसंबर, नहीं तो एक्सटेंड होके वही जनवरी मैक्सिमम।
हाँ हाँ
अच्छा, दोनों सेमेस्टर का एक साथ होगा।
हाँ हाँ
1 2
आप
एंड ऑफ ईयर होगा।
भाई
नहीं,
मैंने अभी ग्रुप में छोड़ा है एक फोटो, वहां पे तो मतलब दिसंबर दिखा रहा है।
देखेंगे
हाँ
क्या होता है।
प्रीवियस असाइनमेंट पास समझे। हाँ दिखा रहा है असाइनमेंट कितना।
अच्छा भाई, एक क्वेश्चन, गोटे क्वेश्चन पचारे थिला, सुनो
कौन?
भाई, हेलो।
हाँ
ये गोटे हूची MCH-11 तो सेटा जून 2025 सेटा लास्ट डेट थिला, जोटा कि स्किप हे गला। बाकी
हाँ
रहिला
हाँ
8टा, 8टा रु 4टा एबा हाइलाइट हेकिना अछि ब्लू कलर रे। बाकी सेटा
अच्छा
हाइलाइट हेइनी, तो बाकी सेटा हम केमति पाइबा? जदि हमें 8टा जाक सबमिशन करबा, बाकी जो 4टा हाइलाइट हेइनी, हमें सेटा
हाँ हाँ
केमति पाइबा?
ସେଇଟା ସେମିତି କହିହବନି, ସାରଙ୍କୁ ପଚାରିବାକୁ ପଡିବ ବୋଧେ,
ସେଇଟା
ସାରଙ୍କ
ହେଇଟା
ନମ୍ବର ଟା
ସାର୍
ଦେଇଦେଲେ।
କୁ କହିଲା ବେଳକୁ ସେ କହୁଛନ୍ତି ନିଜ ନିଜ ରିଲେଟେଡ ରିଜନାଲ ସେଣ୍ଟର କିମ୍ବା ଷ୍ଟଡି ସେଣ୍ଟର କୁ କଣ୍ଟାକ୍ଟ କର କିମ୍ବା ମେଲ କର, ଏତିକି
ସେମାନେ ତ
କହିକି ତାଙ୍କର
ଉଠଉନାହାନ୍ତି,
ପଳେଇବା
ମୁଁ
କାମ।
ତ ଗୋଟେ ଥର ଫୋନ କରିଥିଲି।
ଏବେ ଭାଇ ମୁଁ ଦେଖିଲି ଏଇ କ୍ଲାସ ଟା
हाँ
ଟୋଟାଲ ବେକାର ଗଲା। କଣ ପାଇଁ
ହଁ
ହଉଛି, ଆମକୁ ପୋଷ୍ଟାଲ ରେ ନିଜ ନିଜ ବହି କିଛି ମାନେ ଆସିଛି, ବହିରୁ
ହଁ
ଦେଖିକିନା ପଢେଇ ଦେଇଛନ୍ତି,
ହଁ
ଅଧିକ କିଛି ନାହିଁ। ଅଟଲିଷ୍ଟ ହଁ ସାର୍ ଆସନ୍ତେ କି ମ୍ୟାଡାମ ଆସନ୍ତେ, ତାଙ୍କର ଗୋଟେ ହ୍ୱାଇଟ ବୋର୍ଡ ଥାନ୍ତା, ତାଙ୍କେ ନିଜେ ସିଆଡେ
ହଁ
ଇଏ କରିଥାନ୍ତେ ନିଜର ଗୋଟେ
हाँ
ପ୍ରିପେୟାର।
मते
ଏମାନେ
मते
ଖାଲି
भी
ଜଷ୍ଟ ଓଭରଲୁକ୍
मते
କରିକି
भी
ମାନେ ରିଭାଇଜ କରିଦଉଛନ୍ତି, ତାପରେ ପରୀକ୍ଷା ହଲକୁ ଆମେ ପଳେଇଯିବା, ବାସ୍ ଆଉ କିଛି ନାହିଁ।
मते भी सेमती नहीं थी। ऐसे स्लो कोर्स कंप्यूटर
ହେଲା
एल्मो
ମୁଁ ଫାଷ୍ଟ 15-20 ମିନିଟ୍ ବସିଲି, ମତେ ଆକ୍ଚୁଆଲି ସ୍କ୍ରିନ୍ ଭିଜିବଲ ହେଲାଣି, ତାପରେ ମୁଁ କହିଲି ମତେ ବହି ମିଳିଛି, ମୁଁ ବହିରୁ ଖୋଲିକି ଦେଖିଲା ବେଳକୁ ସେଇ ଗୋଟାକ ବସିକି ଗାଉଛନ୍ତି ଦେଖି ଦେଖି, ଆଉ କଣ
एटा
ଲାଭ?
जो
ହଁ ସେ
ମୁଁ ଏଠି
ଲାଇନ
ଖାତା
ବାଇ
ପେନ୍
ଲାଇନ ବି
ଧରିକି ବସିଲି।
ପଢଉଛନ୍ତି।
ହଁ,
एटा बहिर भी
ମୁଁ
ठीक
କହିଲି
ଅଛି
ହଁ
ना।
କାହିଁକି ନା
ହଁ
ଯଦି ଗୋଟେ ମଣିଷ ଯଦି ପାଠ ପଢଉଛି କିମ୍ବା କ୍ଲାସ ନଉଛି, ମ୍ୟାକ୍ସିମମ୍ ଗୋଟେ କ୍ଲାସ ରେ 4-5 ପେଜ ଆମକୁ ପଢେଇବ, ତାକୁ ଫଣ୍ଡାମେଣ୍ଟାଲ କ୍ଲିୟର ରହିବ। ଇଏ ଏମିତି ଯାଉଛନ୍ତି
ହଁ
ଏକାଥରେ 20 ପେଜ ପୁରା ଏକାଥରେ ଦେଖି ଦେଖି।
ସେ ପୁରା ଡାଇରେକ୍ଟ ବହି ପଢୁଛନ୍ତି ଆମ ଆଗରେ ଆଉ।
नहीं तापर कहलो
ସେଇଟା
लास्ट ईयर टिका ଦେଇଥିଲେ।
ଡେଟ୍ ବି ପାଖେଇ ଆସୁଛି, ସେ ତାଙ୍କର ଯେମିତି ସିଲାବସ ଟା ସାରିବେ ସେଇ ଅନୁସାରେ ତାଙ୍କର ମାନେ ପଢଉଛନ୍ତି ଆମକୁ।
हेलो
ସିଲାବସ ଛାଡିଲେ ଗଲା ସଇଲା, ପିଲା ଯାହା କରନ୍ତୁ।
हेलो
ହ୍ୟାଲୋ।
हाँ ମୁଁ କହିଲି
ହଁ କୁହ
ଲାଷ୍ଟ
କୁହ।
ଇୟର ଯୋଉ ପିଲା ପରୀକ୍ଷା ଦେଇଥିଲେ ତା ଦେହରୁ 90% ପିଲା ଫେଲ, ବୁଝିଲେ କି?
କ୍ଲାସ ତ ଠିକ
ଆଉ
ନାହିଁ,
ତା
ଆଉ
ମାନେ
କେମିତି
ଆମେ
କିଏ ପାସ୍
ହବା ନା
କରିବ
ଫେଲ
କି?
ହବା?
90%
ନା
ପିଲା ଫେଲ, ତେଣୁ ସେଇ ଅନୁସାରେ ସେ କହିଲେ ସେ ଲେଖିକି ଆସିଲି, ମୁଁ ଲେଖିଲେ ପାଠ ଲେଖିଲେ ହବ ନା, ଆଉ ତମେ କଣ ଲେଖିଲ?
ଭାଇ
ଆଉ ଏପର୍ଯ୍ୟନ୍ତ ବହି ଖୋଲା ହବାକୁ ନାହିଁ।
ହଁ ସେଇଟା ବି ଗୋଟେ କଥା।
ମୁଁ ଆଜି ତ
ଖାଲି ଯା
ଆଜି ଯୋଉ ଶୁଣିଲି ଯେ ଆମର ଡିସି ଭାଇନା ପଠେଇଲାରୁ ମୁଁ ଦେଖିଲି କଣ ଗୋଟେ ମିଟିଂ ହେଲାଣି। କ୍ଲାସ ଗୋଟେ ବହି ଥିଲା ପୁରୁଣା ବହି, ତାକୁ କାଢିଲି ହେଲେ
ହଁ
ଯୋଉ ଇକ୍ୱେସନ ଗୁରା ଦେଇଛି କିଛି ମୁଣ୍ଡରେ
ହଁ
ପଶୁନି, ବସିକି ସେଠୁ ଶୁଣିଲିନି, ଯାହା ଗପିବା କଥା ଗପନ୍ତୁ, ଦେଖାଯିବ ଯାହା ହବ ଆଉ।
ଆଜି
ପାଳିଆ ଭଳିଆ
କୋଉ ଯାଏଁ
ଲାଗୁଛି।
ପଢା ହେଇଛି ଟିକେ କହିପାରିବ କି?
ଆଜି ପଢା ହେଇଛି ରିଲେସନ ବିଟୱିନ୍ ହେଲମଜ ଆଉ ଗିବ୍ସ ଏନର୍ଜି।
ବହି ମିଳିଛି ସାଇଡ୍ ପଢି ଦିଅ ଆଉ କିଛି କ୍ଲାସ କରିବା ଦରକାର ନାହିଁ।
ନାଇଁ ଆମର ଇ ଜ୍ଞାନ କୋର୍ସଟା ମୁଁ ପଠେଇଦେବି ହେଲା କି ଡାଉନଲୋଡେड ଅଛି ଯୋଉମାନେ କିଛି ନାହିଁ କଣ କରିବା କହିଲ ବାଇଣ୍ଡିଂ କରିଦବା।
ହ୍ୟାଲୋ
ହଁ ହ୍ୟାଲୋ।
ଏବେ ଓନ୍ଲି ସେମିଷ୍ଟର 1 ଏକ୍ଜାମ ହଉଛି।
ହଁ ଏବେ ନାଇଁ ଦିଟା ହବ ଏବେ ସେମିଷ୍ଟର 1 + 2 ହବ। କିନ୍ତୁ ୟାର
ଡିସେମ୍ବର
ଗୋଟାକ ସବଜେକ୍ଟ ର
ନାଇଁ ୟାର
ମୁଁ କହିଲି
କଣ୍ଡିସନ ମନେକର ତମେ ଚାହିଁବ ସେମିଷ୍ଟର 1 ଦବା ପାଇଁ ତମେ ସେଇ 5ଟା କି 4ଟା ଫର୍ମ ଫିଲଅପ ଦେଇପାରିବ। ସେମିଷ୍ଟର 2 ଟା ପୁଣି ତମେ
ଆମେ
ଜୁନ୍
ଜଏନ୍ ହେଇକି ଓନ୍ଲି ଡିସେମ୍ବର ହେଇଯିବ ନା?
ହ୍ୟାଲୋ
ନାଇଁ ଆମର ଆନୁଆଲ ଏକ୍ସାମ ଟା ହଉ ତମେ ଡିସେମ୍ବରରେ କି ଜାନୁଆରୀ ଟୋଟାଲ ଯୋଉ ଅଲ ପେପର୍ସ ଦବ ସେମିଷ୍ଟର ପ୍ଲସ ସେମିଷ୍ଟର 2
ଆମେ ଚାହିଁବା ଓନ୍ଲି ସେମିଷ୍ଟର 1 ଦବା ପାଇଁ ତାହେଲେ ଦେଇପାରିବା।
ହଁ ତମେ ଯଦି ଚାହିଁବ ସେତେଟା ମାନଙ୍କର ସେମିଷ୍ଟର 1 ଦବ ତାହେଲେ ସେମିଷ୍ଟର 1 ତାର ସେମିତି କଣ୍ଡିସନ ଅଛି। ସେଇ 4ଟାକୁ ଫର୍ମ ଫିଲଅପ କରିକି ସେଇ 4ଟାର ଆସାଇନମେଣ୍ଟ ଦବ। ଆଉ ଯୋଉ ରେଷ୍ଟ ସେମିଷ୍ଟର 2 ଟା ତମେ ନେଇପାରିବ କୋଉଠି ଜୁନରେ ଦେଇପାରିବ।
ପୂର୍ବରୁ ଯୋଉ ଫର୍ମ ଫିଲଅପ ସେମିଷ୍ଟର 1 ଏକ୍ଜାମ ହେଇଯାଇଥିଲା ନା?
ନାଇଁ କିଛି ହେଇନି।
ଏକ୍ଜାମ କିଛି ହେଇନି ଆମର।
କିଛି ହେଇନି ଏପର୍ଯ୍ୟନ୍ତ।
ଆସାଇନମେଣ୍ଟ
ଏବେ ତ
ସବମିଶନ
ଷ୍ଟାର୍ଟ
ପାଇଁ
ହେଲା କ୍ଲାସ ଆଜିଠୁ।
ନୋଟିସ ଆସିଥିଲା।
ସିଏ
ନୋଟିସ ଦେଇଥିଲେ
ତମେ
କିନ୍ତୁ
କୋଉ ସେସନରେ ଜଏନ କରିଥିଲ?
ଆମର ଏଇ ଭୁବନେଶ୍ୱର କେନ୍ଦ୍ରାପଡ଼ା ଅଛି।
ହଁ ମାନେ କେବେ କୋଉ ଇଏର ବ୍ୟାଚ୍ ର ଜାନୁଆରୀ 25?
ଏବେ ହଁ ଜାନୁଆରୀ ସେକ୍ସନ।
ତ ଆମର ଏବେ ଷ୍ଟାର୍ଟ ହେଲା ନା ଆଜିଠୁ କ୍ଲାସ ଷ୍ଟାର୍ଟ ହେଲା କିଛି ଏକ୍ଜାମ ବି ହବାର ନାହିଁ ଆମର।
ହେଲା।
ଆଚ୍ଛା
ସେ ଲେଖିଛି ସେମିଷ୍ଟର ବଟ ସେ କରୁଛନ୍ତି ଇୟରଲି ହିଁ ଏକ୍ସାମ କରୁଛନ୍ତି।
ହଁ
ତମ ଉପରେ
ଲାଷ୍ଟ
ଡିପେଣ୍ଡ ତମେ କେତେଟା ପେପର ଦେଇପାରିବ। ତମେ ଗୋଟେ ସେମିଷ୍ଟରରେ ବି ତମ ଉପରେ ଡିପେଣ୍ଡ କରେ ତମେ 4ଟା ଗୋଟାଏ ଦବ ସେଟା ତମ ଉପରେ ଡିପେଣ୍ଡ କରେ।
ଦେଖ କଣ ସିଷ୍ଟମ ହଉଛି ନାଇଁ ଗୋଟେ କଥା ଶୁଣ
ଏବେ ଯୋଉ ଆସାଇନମେଣ୍ଟ ସବମିଶନ ଯୋଉ ସେପ୍ଟେମ୍ବର କହୁଛନ୍ତି ସେଇଟା ଯୋଉ 5ଟା ଆସିଛି ସେ 5ଟା ଯାକ ଦବାକୁ ପଡିବ କି ପେପର?
ନା ସେପ୍ଟେମ୍ବରରେ ହଉଛି ଆମର ଆସାଇନମେଣ୍ଟ।
ହଁ
ଆସାଇନମେଣ୍ଟ ସମ୍ପୂର୍ଣ୍ଣ
ଆସାଇନମେଣ୍ଟ
ଦବାକୁ ପଡିବ।
5ଟା ଆସିଛି ନା ଯୋଉ 11, 12, 13, 14, 15 ଏ 5ଟା ଆସିଛି ନା କୋଶ୍ଚିନ ଗୁଡାକ।
ହଁ ତମେ ଯେତେଟା ଏକ୍ସାମ ଦବ ତାରି ଆସାଇନମେଣ୍ଟ ଦବ।
ଆଚ୍ଛା। ମୁଁ
ଆକ୍ଚୁଆଲି
ଅଲରେଡି
ମୁଁ ଟିକେ ଦେଖ
ଆସାଇନମେଣ୍ଟ 4ଟା
ଗୋଟେ
କମ୍ପ୍ଲିଟ
ସେକେଣ୍ଡ
କରି ସାରିଲିଣି।
ଆସାଇନମେଣ୍ଟ ଆପଣ
ମୁଁ ଟିକେ ପଠଉଛି ତ ଗ୍ରୁପରେ ଦେଖ ଟିକେ ଆଉଥରେ।
ହଁ
ଗ୍ରୁପରେ ଗୋଟେ ସେକେଣ୍ଡ ଖାଲି କୁଆଡେ ଗଲା। ଦେଖ ଆମର ଏତିକି ଅଛି ସିଲାବସ ଦେଖ। ଭିଜିବୁଲ ହେଲା ନା?
ହଁ ହଁ।
ଏ ଦେଖ ଏତିକି ହଉଛି ଆମର ଆକ୍ଚୁଆଲି ଏ ବର୍ଷ ଯାକର।
ହୁଁ।
ଏଇଟା ହଉଛି ଫାଷ୍ଟ ବର୍ଷର ଏତିକି କାମ ଆମର 11, 12, 13 ଆଉ 15 ହେଲା କି? ତାପରେ ହେଲା 16, 17, 18, 19।
ହଁ।
ମତେ କିଛି ଶୋ ହଉନି ତ।
ତମେ ହ୍ୱାଟ୍ସଆପ ରେ ଅଛ?
ହ୍ୱାଟ୍ସଆପ ଗ୍ରୁପ।
ହଁ ହ୍ୱାଟ୍ସଆପ ରେ
ହ୍ୱାଟ୍ସଆପ ଗ୍ରୁପ ରେ ଛଡା ହଉଛି ମେସେଜ।
ହ୍ୱାଟ୍ସଆପ ଗ୍ରୁପରେ ବି ମୁଁ ଏଡ୍ ନାହିଁ ତ।
ହ୍ୱାଟ୍ସଆପ ଗ୍ରୁପରେ
ଏଇ
ନାହଁ କି?
ଚାଟ୍ ଗୋଟେ ଲିଙ୍କ ଦିଆହେଇଥିଲା ସେଇ ଲିଙ୍କରେ ଜଏନ କର।
ଚାଟ୍ ରେ ଗୋଟେ କିଏ ମାନେ ତାଙ୍କ ନାଁ କଣ ମୋ ମନେ ପଡୁନି ସେ ଗୋଟେ ଲିଙ୍କ ଛାଡିଛନ୍ତି ସେ ଲିଙ୍କ ରେ ଇଏ କରନ୍ତୁ ଜଏନ କରନ୍ତୁ। ଲାଷ୍ଟ
ହ୍ୟାଲୋ
ଅଛି ଧ୍ରୁବ ଚନ୍ଦ୍ର ପ୍ରଧାନ।
ହ୍ୟାଲୋ।
ହଁ ହ୍ୟାଲୋ।
ହ୍ୟାଲୋ।
ହଁ ଯୋଉ ଆସାଇନମେଣ୍ଟ 11 ଟା ସେଟା କେବେ ଦବାକୁ ପଡିବ? ସେଟା ତ ଏବେ ଯୋଉ କେବେ ଯାଏ ଥିଲା କି ଜୁନ 30 ଯାଏ।
ନାଇଁ ଜୁନ
ଜୁନ 30 ବୋଧେ ଲାଷ୍ଟ ସବମିଶନ ଥିଲା।
ସେଇଟା ଜୁନ ସେସନ ତମେ 2025 ଜୁନରେ ଯେତେବେଳେ ଆଡମିସନ କରିବ ଜୁଲାଇରେ ଆଡମିସନ ତାହେଲେ ତାଙ୍କ ପାଇଁ କି ଥିବ।
ଟିକେ ଲିଙ୍କ ଜଏନ କରିଯାଅ।
ହଁ। କିନ୍ତୁ ଏବେ ଆମେ ଦବା ଯଦି ଆସାଇନମେଣ୍ଟ ସବମିଟ କରିବା ତାହେଲେ ସେ ଯୋଉ 12, 13, 14, 15 ଏଇ 4ଟା କରିବା।
ନାଇଁ ନାଇଁ
ତମେ
ସବୁ
ଯେତେଟା
ସବୁ
ଏକ୍ସାମ
କରିବେ।
ଦବ ସବୁ କରିବାକୁ ପଡିବ, ବଟ୍ ତମ ଉପରେ ଡିପେଣ୍ଡ। ତମେ ଯଦି ସବୁ ଦବ ତାହେଲେ ଯେତିକିଟା ତମେ ଥିଓରି ପେପର ଦେଇପାରିବ ତାରି ଆସାଇନମେଣ୍ଟ ତମେ ଦବ।
ଆକ୍ଚୁଆଲି ଆମର ଯେତେଟା ପେପର ସେତେଟା 200, ଯେତେଟା ପେପର ଫର୍ମ ଫିଲଅପ କରିବା ସେତେଟା 200 ଟଙ୍କା ଲେଖା ଫିଲଅପ କରିବା ହେଲା କି।
ହଁ
ତେଣୁ ଆମର ପାଠ 4 ଦିନ 1600 ଟଙ୍କା ଦେଇକି କରିଦବା। ଯେତେଟା ଯଦି ଫେଲ ହେଲା ପରେ ପୁଣି ନେକ୍ସଟ ସେମିଷ୍ଟାର 3 ବେଳକୁ ଜୁନ କି ଜୁଲାଇ ବେଳକୁ ଯୋଉ ପରୀକ୍ଷାଟା ହବ ସେଇଥିରେ ପୁଣି ଆଉଥରେ ଯୋଉଟା ସବୁ ବ୍ୟାକ୍ ରହିବ ତାକୁ ପୁଣି ଆଉଥରେ କ୍ଲିୟର କରାହବ।
ହଁ ବ୍ୟାକ୍ କଥା କୁହନା।
ନାଇଁ ମୁଁ କହୁନି କିନ୍ତୁ ପିଲାଙ୍କର
ଆରେ ମୁଁ ବି ଜାଣ, ମୁଁ କହିଲି ଇଗ୍ନୋରେ ସବୁ ଏମିତି ହେଇଯାଏ, ହେଲେ ଇଗ୍ନୋରେ ବି ବହୁତ ପିଲା ଫେଲ କରିଦଉଛନ୍ତି।
ଇଗ୍ନୋର ବହୁତ
ସେମାନଙ୍କର ତ ସେଇଭଳିଆ ନା, ଆଉ ବିଜନେସ ଚାଲିବ କେମିତି ତାଙ୍କର। ସବୁ
ସବୁଥିରେ ତ ପୁଣି
କଲେଜରେ ସେ
ପଇସା ବି ନଉଛନ୍ତି ତାପରେ ଫେଲ।
ସେଣ୍ଟର କୁ ଆକ୍ଚୁଆଲି ଗଲେ ଜଣା ପଡିବ ସିଷ୍ଟମ ଟା କଣ, କିଛି କାଳେ ହଉଛି କଣ। ହଁ ଯେପର୍ଯ୍ୟନ୍ତ ଆମେ କିଛି କରିପାରିବାନି।
ଏବେ ବି ଏମାନେ ମାନେ କେୟାର କୁ ଫୋନ କଲେ ବି ଫୋନ ଉଠଉନାହାନ୍ତି, ପିକଅପ୍ କରୁନାହାନ୍ତି ବହୁତ ସମୟ।
କେବେ ଫୋନ ଉଠାନ୍ତିନି ଭାଇ। ତମେ ତ ଆମକୁ ତ ଫିଜିକାଲି 2 ଥର ଯାଇଛି, ତମକୁ ତ ଅଫିସ ନ ଦିଶିକି କୁଆଡେ ପାନ ଖାଇ ବୁଲୁଥିବେ ଆଉ।
ନା ମୁଁ ଗୋଟେ ଥର ଫୋନ କରିଥିଲି ଉଠେଇଦେଲେ, କଥା ହେଇଥିଲେ ଯେ ସେ ପୁଣି କଣ ଗେଁ ଗେଁ ହେଇକି ଗପିଲା ସେତିକି, ତାପରେ ବନ୍ଦ। ମାନେ
ନା ତାଙ୍କର
ସେ
ଗୋଟେ
କିଏ
ଟାଇମ ଥାଏ
ବୁଢା
ନା,
ଟା ଗପୁଥିଲା।
8ଟା ରୁ 12ଟା ଯେମିତି ଟାଇମ ଥାଏ ସେଇ ଟାଇମ ଭିତରେ
ନା
କଲେ ତ
ନା ନା
ଉଠାନ୍ତି।
ସେଇ ସକାଳ ଟାଇମ ରେ ଫୋନ କରିବ ନା, କଣ ରାତି ବେଳା କି 4ଟା ବେଳେ ଫୋନ କଲେ ସେମାନେ ଉଠେଇବେନି।
ହଁ ତାଙ୍କୁ ଥାଏ ଯେ 8ଟାରୁ 10ଟା କି 12ଟା
ସେଇ
ସୁଦ୍ଧା ଥାଏ।
10ଟା 11ଟା ଭିତରେ ନା 10ଟା 11ଟାରେ ତାଙ୍କୁ ଫୋନ କରିଥିଲି, କିଏ ଗୋଟେ ବୟସ୍କ ଲୋକଟା ଉଠେଇଲେ, ସେ କଣ ଗପି ଦେଇଗଲେ ଭଗବାନ ସିଏ ଜାଣନ୍ତି।
ସେ ପୁରା ଫୋପାଡ଼ିଲା
ତାପରେ
ଭଳିଆ
କହିଲେ
କହିବେ।
ସେଇ କଥା ତ, କିଏ ବୁଝିବ ପୁଣି କିଏ, ତାଙ୍କ ପାଖକୁ ମାନେ ଡାଇରେକ୍ଟ ଗଲେ ଯାଇକି ଯାହା ବୁଝି ହବ, ନହେଲେ ଫୋନ କଲେ ନାଇଁ, ଫୋନ ଉଠେଇବାର ନାଇଁ, ଆଟେଣ୍ଡ କରିବାର ନାଇଁ।
ନାଇଁ ଠିକ ଅଛି, ଆମେ ସମସ୍ତ ଗ୍ରୁପରେ ଆଡ ହେଇଗଲେ ବି ଦେଖିବା ପ୍ରିପାରେସନ
ହଁ
ସମସ୍ତେ ଷ୍ଟାର୍ଟ କର। କଣ ପ୍ରୋବ୍ଲେମ ହଉଛି ସମସ୍ତେ ସେୟାର କଲେ ଆଇ ଥିଙ୍କ ବେଟର ଇମ୍ପ୍ରୁଭମେଣ୍ଟ ହବ। କଣ କଣ
ଭାଇ
ଅସୁବିଧା
ଯିଏ
ହଉଛି
ତାହେଲେ ଜାନୁଆରୀ ସେକ୍ସନରୁ ଯିଏ ଆଡମିସନ ହେଇଥିବେ ତାହେଲେ କେତେଟା ଆସାଇନମେଣ୍ଟ ସବମିଟ କରିତେ ପଡିବ?
ସବୁ କରିପାରିବେ କିଛି ଅସୁବିଧା, ଏ ବର୍ଷ ପାଇଁ ତମ ଯେତେଟା କ୍ୟାପେବୁଲ ତମେ ସେତେଟା ସବୁ ଏକ୍ସାମ ଦେଇପାରିବ। ଆକ୍ଚୁଆଲି ମୁଁ ଯୋଉ
ଆଜ୍ଞା
ପଠେଇଲିନି ଫଟୋଟି
ହୁଁ
ଆଜ୍ଞା।
ଏ ବର୍ଷ ପାଇଁ ଆମ ଟୋଟାଲ ସବୁ ସେତକ।
ନାଇଁ
ଏ
ଯୋଉ
ବର୍ଷରେ
କହୁଥିଲେ ଯୋଉ 200 ଟଙ୍କା ଲେଖାଏ ଯୋଉ କଣ କହୁଥିଲେ ସେଇଟା ଯାହା ଗୋଟେ
200
କଣ
କୋର୍ସ ଫି ଏକ୍ସାମ ଦବାକୁ ବସିବ ଯୋଉ
ଫର୍ମ ଫିଲଅପ ଯୋଉ
200
କରିବନି
ଟଙ୍କା ଲେଖା ଦିଆହବ।
ଆଜ୍ଞା ଆଜ୍ଞା।
ଫର୍ମ ଫିଲଅପ ଟା ପର ସବଜେକ୍ଟ 200 ଟଙ୍କା। ସମସ୍ତେ ଜଏନ କରିଗଲ ତ ଗ୍ରୁପ?
ହଁ ହଁ।
ହଁ
ହଉ
ହଁ
ଠିକ ଅଛି, କାଲି କ୍ଲାସ ହଉ ଦେଖାଯାଉ କଣ ହଉଛି ଆଉ।
ଓକେ ଗୁଡ ନାଇଟ୍।
ଗୁଡ ନାଇଟ୍ ଆଉ।
ମନ ଦେଇକି ପଢି ପକାନ୍ତୁ ସମସ୍ତେ ଆଉ, ନହେଲେ ତ ବେଷ୍ଟ।
ହ୍ୟାଲୋ।
ହଁ ହ୍ୟାଲୋ।
କୋଉ ଗ୍ରୁପ କହୁଛନ୍ତି? ଏଇ ଯୋଉ MSc ଇଗ୍ନୋ ଏଇ ଗ୍ରୁପ ଟା ନା ଆଉ ଗୋଟେ ଏଇଟା
ନାଇଁ
ଇଗ୍ନୋ
ନାଇଁ ଆମର
ଆର୍ସି ଭୁବନେଶ୍ଵର?
ନାଇଁ ଏବେ ଗୋଟେ ପଠାଇଛି ଲିଙ୍କ ଦେଖୁନାହାନ୍ତି ମେସେଜ ସେକ୍ସନ ରେ।
କେମିଷ୍ଟ୍ରି ଜୁଏଲ ଇଗ୍ନୋ।
ମେସେଜ ସେକ୍ସନ କୁ ଯାଆନ୍ତୁ, ତାର ଲିଙ୍କ ପଠା ହେଇଛି।
ସେକ୍ସନ ରେ ପାଇଲେ?
ହଁ ହଁ।
ହଁ ସେଇ ଲିଙ୍କ ରେ ଜଏନ କରିଦିଅନ୍ତୁ।
ଓକେ ଥ୍ୟାଙ୍କ ୟୁ।
ହଁ ୱେଲକମ୍।
ଆଉ ସମସ୍ତଙ୍କ ପଢାପଢି ଭଲ ଚାଲିଛି ନା?
ଆଜି ତ ବହି ଖୋଲା ହେଲା ଆଉ ପୋଥି ଆଉ। ଆଜି କ୍ଲାସ ଷ୍ଟାର୍ଟ ହେଲା ବହି ଖୋଲା ହେଲା।
ହେଲେ ଆମେ ଡିସେମ୍ବର ସେମିଷ୍ଟାର 1 ହିଁ ଦେଲେ ହେଇପାରିବ।
ନାଇଁ ଦିଟା ପାଇଁ ନଜର ରଖ, ପ୍ରିପାରେସନ ଦିଟା ସେମିଷ୍ଟାର 1 ସେମିଷ୍ଟାର 2 ହେଲା, ବାକି ସେଇ ଟାଇମ ରେ ଯଦି ମନେ
ଆସାଇନମେଣ୍ଟ 5ଟା ଆସିଛି, କୋଉ ପେପର ଆମେ ଦେଇପାରିବା? 4ଟା ପେପର ଦବାକୁ ପଡିବ।
ତାହେଲେ 13 14 ଏଇଟା ଦବ ପୁରା। ଆସାଇନମେଣ୍ଟ ବର୍ତ୍ତମାନ ଦବ 11 12 13।
ତେର 15।
ହଁ 11 12 13 15। आउट ऑफ
14-15 दुईटा रहउची जे बायोलॉजिकल केमिस्ट्री रखिथिबो से सबमिट करबा जे मैथमेटिक्स रखिथिबो सेटा ऑप्शन दुईटा जो हां दुईटा जोटा गोटे जे रखि
सेटा 14 15 अछि बोधे
हां 14 अछि मैथमेटिकल और 15 अछि बायोलॉजिकल ना।
अच्छा आमे भी चारटे पेपर असाइनमेंट लेखिकी सबमिट करिया पड़ियो।
तमे जदि चाहबो दीटा सेमिस्टर दबा पई देन 8टा पेपर असाइनमेंट सबमिट करियो पड़िबो। आ
एपे तो
जदि
बाकी
गोटे दबो
5टा ही आछे ना
नहीं 5टा आसुची
आसुची बाकी तमे सेत्रो 4टा लिखिबो कारण तमर जदि बायोलॉजी रखिबो 14 नले 15 जुआड गोटे करिवो।
हां मु 4टा ऑलरेडी लेखि साची सेप्टेम्बर रे दबा पई परा
11 12 13 लिखिचो देन आ कोटे बायोलॉजी रखिचो ना मैथमेटिक्स
मैथमेटिक्स रखिचे
सेटा कंप्लीट कर देइछन त
हां कर दी छे।
आ बाकी सेकंड सेमिस्टर पई जो 4टा रहउची से असाइनमेंट आसले लिखिबे आ लिखिके डिपॉजिट कर।
अच्छा अच्छा
आपण ग्रुप रे एउटा काम करंतु से असाइनमेंट लेक्चर सब स्क्रीनशॉट शेयर करंतु आमे लेखिबो सेथुरु।
मो पाखरे पीडीएफ अछि ऑलरेडी जदी
अरे
पाबे
ଟିକେ
सेंड
ପଠାନ୍ତୁ
करते
ପଠାନ୍ତୁ ଟିକେ ମ୍ୟାଡାମ ନିହାତି ଟିକେ ପଠାନ୍ତୁ।
ये पठाई दियंतु मैम आ कोन करिया।
आनी मते गोटे सार्ट टी ठकी देला बा
किए
तांके
किए
कहले गोटे सार्ट टी मो ये असाइनमेंट पे मो मेसेज करली आ गोटे
हाँ
मैडम पाखरे मते 30 रुपीस रे मिली गला से सार्ट रो बाकी मोठो पर पेपर 139 नै गले दीटा पेपर 139 लेखा नै गले।
ना आपण सेटा पीडीएफ टा पठांतु प्लस ता डिजाइन कोन केमि करछन आपण जो बनेचंती तार ଟିକେ फ्रंट पेज ता फोटो ଟିକେ
मो
पठेले
तार फ्रंट पेज और ये कने सेटा तो गूगल रे मिलियो मो जहा
ना
बाकी लेखिकी रखी देछि
अच्छा अच्छा
डिजाइन करनी
ଟିକେ ପଠାନ୍ତୁ ମ୍ୟାଡାମ ଟିକେ
हां सेटा पीडीएफ टा पठे दियंतु हम खाली करू।
सेति भाई तो टैक्स पड़ियो
अच्छा जा टैक्स ना वैट कोन पड़ियो।
मैडम 30 रुपीस दबो आ
अच्छा हो
पठे दियंतु आ
पठे देबे।
हां बाय गुड नाइट।
हां गुड नाइट।